This 2-hour sleep story was generated on Autopilot by this AI system. Because if you haven't seen them before, if you just search sleep story on YouTube, you'll find several examples of channels getting millions of views and hundreds of thousands of subscribers by creating long-form videos that tell a story with just a few images to accompany them. And it makes sense when they get popular because remember, YouTube prioritizes watch time as their metric. And so when people listen to videos like these overnight, they get value from them because they learn something new. They seem to help people get to sleep better, and it also builds up watch time for these channels. And so you can see these examples have been fairly successful, and you also have some videos that are only 20 minutes long but with millions of views. And I also compiled a list of other channels like it, which we'll also discuss near the end. And so once you have this system, our AI agent will create a story based on any niche that you feed it. It will create the images to go with that story, create the voiceover for the whole video, and post it to YouTube on Autopilot. You can listen to an example at the latter chunk of this video, but a few other story categories depending on your interest can be meditation for sleep,
slowly relax, and cultivate inner tranquility.
Teachings, for example, for stoicism,
ourselves in the world of Marcus Aurelius,
bedtime stories with familiar characters,
into the untold tales of the Mario Brothers,
trivia and facts to sleep to,
The presence of dark matter bends the very fabric of space.
classic stories told in new ways,
to support new retellings of your favorite worlds,
history and stories about the past,
where we wander through the less traveled paths of the past.
and whatever it is that you are interested in. And if you're intimidated by technical jargon, don't worry because the tool we're using is all no-code anyway, so anyone can learn it. And also, if you're serious about tapping into how to best use AI, which is clearly reshaping everything, and with demand for AI agents and automation climbing fast, if you look at Google Trends, then learning how to build these AI systems is certainly a worthwhile investment of your time. Let's get started. Hey, if you're new here, my name's Jay. I spent a decade in creative and marketing work and half a decade leading data teams, and now founded my AI agency and RoboNuggets, which is our education arm. We have several hundred members now, all AI builders across the globe. And here, our mission is to make creating with AI easy to learn no matter what your background is. We do that through a wealth of AI lessons that most people join for, but most members stay because of the community that we have built. And like always, to make this lesson as easy as it can be, I've organized this workflow into steps, and I'll also be running through it in detail so that you can understand the principles of how it's built. In this system, we created it in n8n. And if you're completely new, n8n is a no-code automation tool similar to Zapier or Make, but you can see how popular it's gotten because of the way that it integrates AI into their tool. And what's great about n8n is if you're a bit more advanced and need a shortcut, if you're part of the community, you can just download this template along with all the resources and prompts, import that file into n8n, and that will create the workflow for you automatically. And you can also use this template to copy all the prompts that we have here if you're following along the tutorial and want to learn step by step. So with this system, there's essentially 3 big parts. First, we'll arrange the input section so that we can have our AI agent craft the chapters for us. Then we go and create images for those chapters. And then finally create the video itself with a subsection to generate the voiceovers through these nodes. So when you're in n8n, just click create workflow at the top right. And then for the first step here, just add in a trigger. So for this tutorial, I'll add a basic trigger where it executes when I click this. And the next step you want is to find the Google Sheets node, specifically the get rows in sheet function, and just rename that to get idea, because what this node will do is it will get your video idea from your G Sheet. And if you're completely new to n8n's design of working, for every node that you configure, there's always 3 windows. The one on the left is the input region, where you'll see all of the data or information coming from previous nodes. Here in the middle is all the configuration settings of the node that you are setting up. And then you have the output section, which shows the output of that node itself, which it will then pass along to succeeding nodes. So if you go back to the Google Sheets node, you'll see that same design of working as well. And to set this up, you just need to first set up your credential if you haven't yet by clicking on this and signing in with Google here. And once you've connected that, if you click this drop down, you'll be able to see your Google Sheet templates in this list. So for the template, we can just grab it here in the course page, and here we can make a copy of that, and that should load a simple Google Sheet template into your Google Drive. So I'll go through these columns in a bit, but just back in n8n, we just want to link to that Google Sheet and also select our first tab here, which is Sheet 1, which is that tab that we are viewing. And we just want to add a filter here where the column called status is set to create. And if I scroll to the right here, you'll see that this is that column, and we're just going to instruct this node to grab all the information in that row. Last thing you want here is to add an option for return only the first matching row so that we get one idea or row at a time. So if I execute this step, you'll now find under the output schema here, that specific row with all of the information on the video that we are about to create. So the question now becomes, what are all these columns and how did we get this idea in the first place? Well, these first 5 columns are pretty self-explanatory. You can fill them up yourself, or you can also offload the ideation to any AI model that you use. In fact, here we created a GPT just for this, where if you ask it for ideas and also an image for the visual style reference, what it will do is generate video ideas for you, which you can just copy and paste into this Google Sheet. And once you paste praise that, instantly you'll have the title of your video, the caption, details of what that video is about, as well as details about your YouTube channel, which you can freely edit and review as well. And by the way, this GPT can also give you the prompts for your thumbnails, if in case you want to generate those as well. So you'll see later how we use these columns. But just to complete the view, these columns are yellow, are inputs from yourself in terms of how many chapters you want to generate, as well as how many 30-second snippets each chapter will contain. So for example, for the 2-hour video that we generated, that one has 10 chapters, with each chapter having 24 half-minute segments. So if you do the math, that will be a total of 2 hours. But when you're setting this up for the first time, I suggest to start with small numbers first so you get a feel of how it works. And finally, you can see we have some inputs here around the voice audio as well as the background audio. So if you click on this URL, you can see it leads to an MP3 file, which just contains the voice sample that we want to copy for the length of this narration. So if you play that,
Just tried Robocolon low-key. It's slap. Tastes good. No crash.
and that can be your own voice or a voice file that you can download from platforms like 11 Labs. But once you have that MP3 file, you can see we're uploading it to this service called Cloudinary. And Cloudinary is actually pretty useful for AI automators because they have a generous free plan. And if you go to their assets section, you can upload files here where you can see I have that voice file uploaded here. And if I right click and copy that URL, that is the MP3 file that I just put into this Google Sheet. Now, the other MP3 file that we upload is this background audio. And if we go to that link, you can see that it's just rain sounds that is 30 seconds long. Same as before, I have it uploaded in Cloudinary, and this is the URL for it if in case you want to use that as well. So with that, we now have our inputs for the video, which we have also loaded in n8n. And so if we click away, the next node to add is our AI agent node, which we can just rename as such, which by the way, if you want to follow this step by step, it's best to rename the nodes properly now as I type them here, just so you don't get naming mapping errors down the line. But when you set up an AI agent, you want to change this to define below. And here you'll see it's asking for a user prompt, which if we change that to expression and paste our user prompt here, if I expand this, you can see we have a pretty simple user prompt in here where we are asking it to make a story about the following video. And whenever you see this green text, that just means it's a dynamic value. So this chapters, it's mapping back to the chapters column that you inputted in your Google Sheet. So how that translates when you run this automation is it just grabs that input from the Google Sheet here. And that's the same principle for the video title, which we loaded here, the video caption, the video details, where we also pass in that column the visual style and the tone of voice that we want. And then here below is the YouTube channel details. That includes your channel name. And for every AI agent, it's good to always add a system prompt, which you can click here under options. And again, if we change that to expression and copy in our system prompt here, if I expand this, what the system guideline does is to give the AI agent with some instructions on what to do with that user prompt that you just gave it. And this also aligns with our agent framework where we note down what our ask is from this agent, some guidelines on what to do and what to avoid, an example of what good looks like, the notation or structure of what this agent's output should be, which you can see here is in the JavaScript object notation format. So I'll talk more about that in a bit. And then finally, the tools that this agent may have access to, which is an option for you to add if you are a bit more advanced. So if you click away, if you execute this step, it will error because it's requiring you to add a chat model here. So if you go back, the chat model is sort of like the brain of this AI agent. So when you click that, you have a lot of options here, which are familiar names in the AI space. The one we'll use is OpenAI since they're the most popular. And to connect your credential there, just create a new credential like before. And then you'll see it's going to ask for your API key, which you can grab in this URL by OpenAI, and then just paste that there. And when you save that, you can now connect to your OpenAI account. And the model to use that I suggest for this one is 4.1. The other thing that you want to add is what's called a structured output parser. So if I reopen this and toggle this on and go back, this output parser subnode now shows, and you just want to click this structured output parser. And then under JSON example here, just paste in the output structure that you want your agent to follow. And if we expand this, you can see this JavaScript object notation format. So whenever you see these brackets and braces, this is what JSON is. And it's just a format that a lot of computers already understand. But very simply, you'll see that we're asking for these 4 values for each and every chapter, which you will also see if you click away and just run this AI agent. What it's now doing, once it's done its job, if you open that, you'll see in its output that it now created 3 chapters for us, because remember, that's what we asked for in the beginning with the Google Sheet. And if you unfurl each of these chapters, it would give you the chapter number, the chapter title that it ideated, the description of what happens in that chapter, as well as a prompt for the chapter's image. So you'll see how we use that in a bit. But just to complete the input section, you just want to have a split out node next. And you want to drag the chapter's output into the fields to split out and execute this step. And what that basically did is ungroup the output of that agent, which it was giving as one item, and just unbundle them into 3 specific items, which you can see if you go to the table view here. And the reason why that's important is because the next node that we want is going to be another Google Sheets node, specifically this append row and sheet function. And what this node will do is log our chapters for us. So like before, you just want it mapped to that same Google Sheet you were working with, but this time you want to map it to Sheet 2. And if we go to Sheet 2 of our Google document earlier, you'll see we have a couple of columns here that's just meant for logging purposes. And when you connect it to Sheet 2, n8n has also obtained those columns here. And so since this is just for logging, what we'll do is just drag the info that our preceding node has given us and just put them into their respective columns like what I am doing here. So that should log the chapters that we created. But also for tracking, we just want the video ID and title in there as well, which comes from your very first Google Sheet node. So I'll just drag it like this. And then for this execution time and ID, you can just get that from variables and context here at the left. So I'll drag this now attribute, and that should give when this node will execute, and also this execution ID, which you'll see later how that helps us in our tracking. And then finally, before you leave this, you can set the status to create, and that should be all of the columns that we want to add. So now if I execute this step, what happened is it logged those 3 items into our Google Sheet, and most importantly, the chapters that we're about to create. And there you go. That is now the input section done. So remember to just save your workflow. And also what you can do is to just highlight all of these nodes and press on P in order to pin the information there so that you don't have to regenerate those chapters and prompts if in case you need to come back to this workflow to build it out. So now the next thing to do is to set up our nodes that will create the images for each of those chapters. So for the next node, to make it easy, you can just copy this get idea Google Sheet node, press on P to unpin that, and just link it like so. And if we open this, we can just rename this to get chapters. It's still linked to our Google document, but you just want to change this into Sheet 2 because what we'll be doing in this case is to reload the chapters back into n8n. So I'll explain in a bit how that is useful, but the way you do this is to just set the column to find the execution ID, and then under value, you want to map this execution ID from the previous node. And last 2 things that you want to do is to just toggle this off so that you return all of the chapters in this case. And under settings, you want this node to execute only once. And when we execute that step, we now get those 3 chapters that we are about to create images for. And it's just useful to have a node that will re-obtain the information here, because in practice, as you run this workflow, you may want to check if the chapter titles and the image prompts are to your liking. So if you do any manual edits here, this node will be able to capture all of those changes. Now, if we revisit our main workflow, you can see that the next node here is this sub-workflow node. And sub-workflow essentially is a grouping of nodes. So if you just go to that one, you'll see that the create images node has this sub-workflow within it, which we'll be setting up in just a bit. But the reason why sub-workflows are really useful is because when you set it up once, you can just copy it into any new build that you will deploy, and you'll be able to use them much easier. So how do we now set up this sub-workflow in n8n? So what we'll do next is add in an edit fields node where we just want to drag in our image prompt here, and we want to add another field that we can name as aspect_ratio, and just type in 16:9 because we'll be creating landscape images in this case. Now, if you execute this step, what it basically did is grab those values that we wanted, which we will now pass to an HTTP request node. And this node is the main way by which you can call on third-party tools from within n8n. And to use it, you just want to set this to post. And under URL is where you'll send your request to. So you can see here the service we're about to use is called key.ai. And if you go to key.ai, you'll see that they're basically an AI model aggregator. So sort of like an app store, but for AI models. And the one that we're going to use to create an image is this Seedream API. So if you click that, you can actually test out the model manually here. But to use it in an automation, you need to read through this API documentation, which we have already read through. And so that is where we got this URL to send our request to. And the specific request that we're about to send will be contained under this body, and we'll format it using JSON to make it easy. And if you change this to expression, we just paste in our structure there. And if I expand this, you can see that we're telling Key AI what model we're about to use, what the prompt is, which is, again, a dynamic value that we got from the previous node, what the image size is, which we are passing along here, as well as the image resolution, which I've set as 2K for this run. And by the way, you just want to rename this as well to create image so that you know what it does. But if I execute this step, it will still fail because it's telling us we don't have access permissions yet. So with these requests, the best way to set that up is under authentication, go to generic credential type, go to header auth, and just create a new credential here if you haven't yet. Name this as something that you can find. And then under name, you need to type this out exactly. Authorization with a capital A and no extra space after that word. And under value, you want to change this to expression and then type in bearer with a capital B, space. And then this is where we'll be pasting our API key, which you can get coming from this link and which you should just paste here. But just make sure that this is typed out correctly with a capital B and just one space in between and no trailing space after your API key, and then click on save. And when you have that, you can now use this credential across your workflows. So now the last thing that I recommend is under options, just turn on batching in this case. And what that will do is send Key AI your requests one by one every 1000 milliseconds or 1 second, just so it lessens the risk of you getting blocked. So if I execute this step, Now it gives me a status code of 200 and it says that request has been successfully passed. So next thing we want is a wait node because we'll be waiting for that generation to finish. This is pretty fast, so you can just set this as 15 seconds. Click on execute step just so that we can continue building out the workflow. And then the next node will be the get image node. So just copy this one, link that there. And if I open this, we can rename that to get image because what we'll be doing in this case is getting the image from KeyAI. So to do that, as per KeyAI's documentation, you'll want to change this URL to this one. The credential can stay the same. And instead of sending a body, we just want to send a query parameter in this case. And as per KeyAI, the way to do this is to give it our task ID, which if you go to create image, you'll find here. So just drag it in there. And this is a unique ID given by KeyAI to us to point to that image that you are generating. So for this case, we can just turn off batching. And now if I execute this step, you can see we have 3 items where we now have some output from KeyAI, including the images themselves. So before we preview those, just last 2 nodes would be to add in this switch node. And just to show why we need this switch node, if I add 2 routing rules in here, rename them to success and in progress, if I go back, this is just a way for us to loop back to our wait node. If I map this in progress branch to here, if in case that image is still generating. And if it's successful, then we continue as planned. So the way to set this up is different for every service, but for KeyAI, you just drag this state parameter and check if that's equal to success. And then for the in progress branch, that state parameter will either say waiting or generating if in case it's still in progress. So we just change this to contains ing just to quickly capture if it says waiting or generating. So now if we execute this step, that should now route to the success branch. And finally, you just want to have another edit fields node in here. Title it as return image, add a field in here, name it as image result. And under value, you just want to change this to expression and paste this here. And what that will do is it's looking at KeyAI's results here and getting the PNG files or the photos, which you can shuffle through here. So if I execute this step, that just gave me those image files in a cleaner format. So now you have this whole sub-workflow that generates images for you using Seedream. And the way you make that into a sub-workflow is to just highlight all of them, right-click, and convert these 6 nodes to a sub-workflow. Rename it as something that you can remember. And once you confirm that, that should now build a sub-workflow for you. So now for future builds, you can use this sub-workflow as well. And for this create image sub-workflow, the other thing that you want to do is to change the mode to run once for each item. And that will just prevent errors for you down the line. So now if we execute this step, and if we open that, it will output for you the images for each chapter that you feed it. You can see these are PNG files, which you can preview in your browser. So this is the image for our chapter 2 in this case. So if you go back to the completed workflow, you'll see that the next step we're about to do is to videofy those images. And the reason why we do this is because later on, as we combine these, it will be much easier and more cost-effective as well. And so to do this, you just want to add a code node first and rename this to stitch command, because what we'll do if you just delete this placeholder, we'll be pasting in this command, which if I expand, you can just copy this piece of JavaScript. And before you click execute, just change this to run once for each item. And once we run this node, what it's going to give you is this command for a service called FFmpeg, which if you're new, FFmpeg is one of the most trusted auto video editing frameworks. They've been around for 24 years now, but traditionally to use it, you need a lot of technical knowledge. But to use FFmpeg easier, we'll be using renty.dev, which offers FFmpeg as a service. And the great thing is they have quite a generous free plan, so you can try it out. And so this command that you generated, you can pass it to Rendy in order to convert your images into 30-second videos. So how do we do that? Well, it's going to be another HTTP request, which we can rename as stitch video. You change this again to post. The URL for Rendy is this one. And then the request itself will be another JSON formatted body. And you just want to drag in that Rendy job into this field. And under options, I also recommend adding batching in here to have this configuration just so that you don't overload their systems. Now, you also need to set up your credential if in case you haven't done that yet. So same as before, click on generic credential type, find header auth, create a new credential here, rename your credential. And to get the name and the value, we can read through Rendy's documentation here, which I've already done. And so under the name, just type in XAPI key in all caps. And under value, just change that to expression. And if you sign up to Rendy, you'll have your API key in the homepage, which you can copy and paste under value here and click on save. So now we can click execute step. When you get these command IDs, that means Rendy is now working on your tasks. And so we just need to set up a wait node here. We'll configure this properly later, but for now, just set it as 1 second so that we can continue building out the workflow. And like before, just copy this previous HTTP request, connect that there. And if I open this, we now change the method to get because we'll be getting the videos. And the URL where we will get it from, if you change this to expression, you can just paste this piece of text where it's basically pointing to those command IDs. Your credential should be loaded here, and then you can just toggle send body as off and remove batching in this case. and rename this to get video from Randy. And if we execute this step, you'll now get the status of those 3 items, as well as the MP4 files in here, which we can cleanly capture if we add in an edit fields node, name this as return, and drag this storage URL into the field and click execute step. And now you have those images videofied into 30-second clips, which again, we can preview like before. So now to clean this up, same as before, we can just convert these nodes we set up into sub-workflows, name it with whatever's relevant. And now you have that sub-workflow. But before we leave this step, there's one edit that I recommend. So if you right click and go to this sub-workflow, that should open the sub-workflow that you just created. And what you want to do is to open up this wait node, which if you remember is still 1 second, and change that into 60 seconds. Now what I found is if you're creating just for 3 chapters, let's say, this is usually more than enough. But if you're creating for 10 chapters, let's say, Randy actually sequences your tasks for your account. And so you need to wait a bit longer. Now, normally we could just edit this wait amount to something like 240 seconds for 4 minutes. But it seems there's a bug in n8n recently where for some workflows, if you have a node that runs for more than 60 seconds, it results to an error. And so what we just need to do for now is to just duplicate this wait node multiple times. So now we have 4 minutes in total because each of these are 60 seconds. And we just connect them like so. And you can also hit this clean icon to tidy everything up. And now you're giving Randy 4 minutes to finish all of your chapters so that you don't run into those errors. So now make sure to save that workflow so that your main workflow can also capture those changes. And now we can just execute this step. And when that finishes, if you open this, that will now give you your videofied images, which as a final step in this part, we will log back to our Google Sheets. And so to log those images, you can go ahead and find the Google Sheets node again, but this time we'll be updating the row in Sheet and rename this to logged images, link it back to your template. We'll log it in Sheet 2. And under column to match on, you want to get the row number. Because if we go back to our Sheet 2 in this case, the goal of this node is to log those image URLs into these cells. So in order to do that, we just need to get the row number from this get chapters node from before, specifically this one, put it in there. And you can see it maps to row number 2 as the first item, which is this one. We also just want to drag in the execution time into this column just for tracking. And then under image URL, you want to drag this storage URL from your Randy sub workflow into here. And when you execute this step, what that has now done is update your Sheet 2 with the image URLs so that you have them properly logged. So there, that is now part 1 done. Remember to click on save and just pin these nodes. So now the next thing we'll do is to create the video itself while also creating the voiceovers during the process. So to do that, the next node will be a copy of this get chapters node, which you can just copy like so. Press P to unpin the data and then just map it back like this. And if we open this, you just want to remap it back properly to your execution ID, which comes from this get chapters node, specifically this one, so you can just drag it there. And you also want to add a column here is what I recommend for the status. Because in Sheet 2, if I scroll to the right, you remember we have this status column. So we just want this to filter for the chapters where we have the status as create. And this just gives you flexibility if in case you want to create for just one chapter, if you're troubleshooting. This is a way to control that. Because then what you can do is just skip those other chapters so that you focus on this one if you prefer. So now if we just rename this node so that we know that it will just get the chapters along with the images this time, if we execute that step, it should now get those chapters that we're about to create scripts for, but this time with the image URL in here. So now before we create the video itself, we of course need to create the voiceover in the script. And to create the script, we're going to have another AI agent do that. So we can actually just copy this whole piece, paste it here, press P to unpin that data there, and just connect it like so. So now if we open this, you can just rename it to differentiate it from the previous agent. And then for the user prompt, we can just paste in the one we crafted. So if I expand this, you'll see that our user prompt just consists of the chapters that we're about to create. And you can actually shuffle through these. And here is also where we are passing the number of script snippets that we're about to create for each chapter. And remember, each script is 30 seconds long. And so you'll see that in action in a bit. But we have a couple more instructions here around what to do for each chapter, which you can just read in your own time. And then at the very bottom, we are passing our channel details, as well as the whole video that we're about to create, just so that it contains that context. And since this agent also has a different objective, our system prompt will also change. So if we just paste the prompt we crafted there, you'll see that this time our ask for this agent is to create the script. We're still giving it guidance on what to avoid and what to do, still giving it examples on what good looks like, what is the notation or structure that we expect, as well as the tools that it may have access to if you want to add that as well. Now, before you run this, 2 things that are useful to change at this point is under settings, toggle execute only once so that we can simulate how this would look for one chapter first. And then for the structured output parser, this needs to change as well. So you can just have a structure like this, where if you view that in full, you can see that we're just requesting from the agent the script snippets in this format. And that goes from 1 up until 20, just so that it has a good example of what we expect. So now we can run this agent. And once that's done, what it now gave you is the script for chapter 1. And you can see this is snippet number 1. This is the second snippet. And each of these are built so that they can be read within 30 seconds. And like we requested, it gave us 4 snippets as well for that chapter. And the reason why we set it up so that the snippet can be read within 30 seconds is because the voice AI model that we're about to use also has a 30-second limit. So if you look into what we're setting up next, that is actually what we're going to do. And so to continue this, we just need another split out node and drag in this script and execute this step. Same as before, we just want that one grouped item to be unbundled. And next we want an HTTP request node. And this one will create the voice for us with a model called Chatterbox. So just change this to post. And this time the URL we'll be sending this request to is through file.ai, where if you go to File AI's Explore page, you can see they are also an AI model aggregator. In fact, I think they're the biggest. They have more than 300 at this point. And if you search for Chatterbox, you'll find this one that we're about to use. And here you can try out the model directly. But to use it in an automation, you need to read through this API tab, which we've already done. So we got this URL from there. But the reason why we're using this model specifically is that its cost is actually very economical. So it's only around 2.5 cents per 1,000 characters. So if you were creating a 2-hour video, let's say, so that is half the cost of other models like 11 Labs, for example. And so back in n8n, we just want to set the body again under JSON. And if we change this to expression, we can paste in the JSON structure for File AI's Chatterbox in there. And if we expand this, you can see we have a couple of parameters in red. And this is actually good so that I can show how to fix this. Because here in the text, we should be passing our script, which is this one. So I can see that the issue is that instead of script input, it needs to be script text. And so when I rename that, it now maps properly into that piece. We also have our audio URL, which would be the URL that you put in your Google Sheet. And so if you go back to the very beginning under the very first Google Sheet node, you can remember that this is also where we had our voice audio here, which to recap is the voice we previewed together earlier.
Just tried Loki. It's slap.
So now to map this properly, you can just drag this in and then just place that whole piece of text into the right field in between these double quotes. And now you have this final piece of structure that you can copy as well, in which if we run, it most likely will result to an error because I haven't set up my authorization yet. So if you're new and you don't have your File AI credentials set up yet, it's the same thing where you just set it up here and just create a new credential. The name will still be authorization. Under value, if you change that to expression so you can see what you're typing, the format will now be key with a capital K followed by your API key after a space. And this is just as per File AI's documentation. And to get that, you can just go to this URL. You can create a new key in here and paste that text right after the space in key. Make sure there's no trailing spaces and the first letters here are capitalized so that this would work. Click on save. Make sure that is selected. And also you just want to add in batching here as well. Change that to 1 item and just execute this step. So when that's submitted, you now have 4 items for your 4 voiceover snippets that are in queue. And so like before, we just wait a bit. We can just execute this step with 5 seconds. We'll edit that later so that we can just proceed with building out this workflow. And the next thing to do is to just copy this, same as before. But now if we open this, this will now be to get the voice coming from File AI. And so to do that with File AI, you just remove this and under your create voice, that should have the response URL, which you can just drag in here. And that is where your voice will be once it is done. So you can just toggle send body as off. Remove the batching in this case. And once you have that set up, just make sure to change this into get and then execute this step. And once a sufficient time has passed, you should now get these 4 items that are WAV audio files. And so just to complete this step, we can add an edit fields node where we can just drag that audio URL in here. And if we click execute that step, we'll have those summarized for us. So now like before, we can convert this into a sub workflow and name it like so. And now before we retest this step, we can just go to that sub workflow. And again, make sure that the wait node is now at a sufficient amount of time. So we just change that to 60 seconds. And same as before, we just duplicate this. So for this one, I recommend 3 minutes in total. So if we map it like this and clean it up, click on save, we can now go back to our main workflow and just test this node so that we make sure that it works. And once that's done, it will now provide those audio files, which you can preview in your browser as well.
In this video, we travel through time to uncover the story of AI. How computers grew from simple...
So that sounds like the voice that you just fed it and also following the script that your AI agent created. So now before we proceed, it's just good to pin these nodes again, just so we don't have to regenerate those. Because now what we'll do is to combine these 30-second audio files with the 30-second video files that we generated earlier. So how do we do that? Well, we can add in another edit fields node in here, just as a starting point for our next task. And then here you want to add in 3 specific fields. One is going to be the audio URL, which is going to be this voiceover audio that you can just drag here. Next one is going to be the video URL. This is now where you load your 30-second videofied images coming from the Get Chapters with Images Google Sheets node, which is the one you just stored here. So just drag that over. And finally, the third field is going to be the background music URL, which if you remember, you loaded in the very first Google Sheets node here. So it would be this one that we loaded in n8n through that very first G Sheet node. So these are the elements that we'll use to be combined. And so if we execute that step, we now have those 4 snippets for this chapter to be created. And so to combine them, what we'll use is another HTTP request. And this one will be to combine the clips. We change that to post because we'll be sending a request into File AI once again. And you can see we're using File AI, but still the FFmpeg framework in order to compose this clip together. So for the authentication, you can just select your File AI credential that you have already set. And then for the request, toggle that on. Let's use JSON once again. Change this to expression and then paste our structure here, which if we open, what you now find here is File AI's structure for using their FFmpeg model, where we are basically passing along the video file, which lasts for 30 seconds. We're also passing the audio, which is the voiceover in this case, also 30 seconds. And then finally, we are passing along our background music, which if you're using this URL, that just has the 30-second soft rain sounds, which is just fit for this track. So if we execute that step, that should now pass our 4 requests to File AI. We just set up a wait node once again. Let's execute it for now so that we can continue building out this workflow. And when that is done, we again just get the video file that we just combined together and rename this to get clip, change this to get. And with File AI, like before, you can just grab this response URL to get your output. You can toggle send body as off. And if we execute that step, we can see if those have been complete. And it seems like it is because now you can see we have 4 video files, which just to end this batch of nodes, we can just set them up with the edit fields node and name this as return. Add a field here, which we can name as combined video result and drag the video URL here. And so if we execute that step, that just cleans those MP4 files for us, which if you just copy this, that now downloads the video file, which if we preview,
Welcome to Future Law, where we transform the complex history of technology.
that now combines the voiceover, the background music, which is the soft rain sounds, as well as that image into this 30-second snippet. So now this whole batch, we can just convert them into a sub-workflow once again, name this as create clips. And before we run this, same as before, we just go to that sub-workflow. We change this to 60 seconds to give it enough time to generate. Click on save. And if we go back to our main workflow, we can now run this just to make sure that it works. And once that is done, that should now give you your MP4 files and confirm that this workflow is working. And so let's just spin this so that it doesn't get lost. And now the final job to be done is with these 4 clips now available to us, we just need to stitch them together to form the video for that whole chapter. So to do that, just add in an aggregate node, drag in this combined video result and execute this step. And we're doing this so that from 4 items, we aggregate them into 1 item, which is a requirement if you want to stitch multiple video files together. And so now with those URLs aggregated, we just have one more step before we can combine them. And that is to set up an edit fields node once again. Add a field here for video URLs, and then change this to expression and then paste this value. So what this expression does is it just gets those combined video results, but it does this thing called stringifying them, which if we expand this, you'll see that what it did is just clean up these MP4 files so that they have the proper format with the double quotes as well as the brackets to form what we call an array, because that is the format we need in order to do the next step. So if we execute this, we are now ready to pass that value into an HTTP request node, which you can just rename to combine to make a chapter, change the method to post once again, set the URL to this one because this is where we'll be sending that request. You'll see we're still using File AI and FFmpeg, but specifically their merge video framework. The authentication will be the same. So just map that to your File AI credential. And then under the body, this is similar. And we just pass along this piece of text, which is the merge video format for File AI, where if we expand that, all that really does is give File AI's FFmpeg the video URLs that we want to merge together. So with this done, we can execute this step. It will say it is in queue. We will wait a bit like before, execute this step for now, copy the HTTP request, same as what we did last time. And if we open this, we can rename this to get chapter, change this to get. And for the URL, remember the response URL for File AI is how we'll get this video. And then if you toggle send body as off, you can execute this step to see if it's complete. And it seems like it is because now we have this URL video with us. Now, before you leave this step, what I want you to do is to go to settings and under this drop down called on error, just change that to continue. And this is just a quirk when it comes to Follow AI, because when you execute this step, and for example, you're merging several videos together, if it's still in progress, Follow AI will actually throw in an error, which stops the whole n8n automation. So to prevent that, we just need to do this in order for the step to still continue if it is in progress. And so since merging videos can vary wildly in terms of how long you should wait, what I recommend is to have another switch node in here. And similar to before, we will just add 2 routing rules. One where it is success and the other where it is in progress. Because remember, the plan is if it's still in progress, we just wait a bit more. And if it's success, we just continue. But for Follow AI, this is a bit different. So for it to be considered a success, you need to check if this URL exists. So just drag in that video URL and then change this condition to it's not empty. So if there's a video URL, then that means it's successful. Now with Follow AI, the way that you find out if it's in progress is if you change this to expression and then type this in, error.message, and change this to contains still in progress, then that means that Follow AI is saying to you that your request is still processing. Now this is red because this previous node is already resulting to a success. So Follow AI didn't actually give us an error message here. But if it does error, then this condition will be triggered and it will trigger it back to in progress there. And so if you run this workflow, I think this will just rerun, but that's okay. And you can see it maps to success. And now to bookend this sub-workflow, we just add a final edit fields node called return. We add a field that we can call as combined video result once again, and then just drag the video URL from the switch node in here and then execute that step. And there you go. You have the merge video, which again, if we preview, you'll see that this video is now 2 minutes long because remember, we had 4 snippets that we combined together to form this chapter. And so with this sub-workflow completed, same as before, we just convert them back to become a sub-workflow and name this as combine clips for chapter. And this is actually the last sub-workflow that we will be creating. Just click on confirm. And again, before we rerun that to test if it works, if you go to the sub-workflow, we just change this wait node to 30 seconds to give it enough time. Click on save. And now we just run this workflow in order to test that it does still work. And once it's done, you can just check the output again to see if everything is set up correctly. So there, so if we organize these nodes, you can just pin these to complete them. And the last thing that you want to do is to update your Google Sheets again to have the final video for your chapter be logged properly. So to make this easier, you can just copy this log images, paste that there, unpin it, and then map it like so. And then if we open this, you can rename this as update chapter because this is still linked to our sheet 2 chapters. And then under row number, just remove that one. And then under the values to update here, the one that you want to remove this image URL just so that it doesn't update, because what we actually want to update is this final chapter URL, which if you remember our sheet 2, it's going to be loaded in this column. So to get this, you can just find it in the very last node that you had, this combined video result, and drag it there. And also you want to update your status to done so that that chapter is marked as done when it's finished. And so what's missing for this node is for it to know which specific row it should update. So I'll show how to do that in a bit. But for now, just add in manually the row of the specific chapter that we're updating, which is chapter 2 in this case. And then later, as we go and do the loop function, we'll be changing this to an expression as well. But if we click execute step here, what it should now do is update that chapter with that merge video that we just viewed together. So now we did it for one chapter. How do you now do it for the remaining chapters that you want to create for? Well, if you go back to n8n, what you now want to add after this is to find this node called loop over items. And when you add that, n8n automatically has this placeholder which you can just delete. And also this loop, you can delete this line as well. And then to configure this, all you need to do is to map this loop into your AI agent. And then instead of mapping from your Google Sheets here into your AI agent, you can just delete that. You map it into this loop function here. And so we can just clean this up so that it looks similar to what we had in the beginning. And now what will happen is, if you remember, we are going to create for 3 chapters. That's why there's 3 items being passed into this loop. We'll be running these nodes one at a time for each of those chapters, mainly because we don't want to overload our AI agent when it's time to create 10 chapters at a time. And so before we test this out, 2 things that you need to do would be, number 1, you can just rename this to loop for chapter videos. And just make sure that the batch size is 1 so that you create for 1 chapter at a time. And then under update chapter, if we open that again, for this row number to be dynamic, because remember, this should map to the chapter you're creating for, just make sure it is an expression and then paste this in. So you can see the row number we are going to get from the loop for chapter videos, which we just added. So now if you set everything up correctly, what you can do is to just unpin all of these nodes, make sure none of them are purple. And for you to test this out, just add a node here in the done branch, specifically this aggregate node, because that's the one that will be coming next. And lastly, the other thing that you can disable is if you click on this AI agent, go under settings, you can just disable this execute once, just in case in the future you want to create for multiple chapters at a time. So now to test this workflow, what we'll be doing is to click play on this node. And what is now happening is that n8n is passing along one chapter at a time to this AI agent to create the script for that chapter. It will now create the voice for each of those snippets, which it will now combine with our visuals that we set that we generated earlier and combine all of those snippets in the end in order to create the final video for the chapter. And depending on how many chapters you created, that can take a bit long. But once that is done, if you open this loop node, that should now have all your chapters under the done branch. And you can see that you have those videos for each of the chapters that you created here. And so before we proceed, it's just good to pin these nodes again, just so we can retain that information. So now the last 3 nodes that you just want to set up is this aggregate function, which is pretty simple. You just drag this final chapter URL in order to group those 3 items into one. And so if we execute that step, it's possible it may run twice just because you pinned the loop node just now. But if you execute it again, you should now have your chapter videos all aggregated into one item. Because what we'll be doing next is to combine all of those chapters into one video to make our final long form video. And what we'll do to do that is this same sub-workflow. So you can just copy that, paste that here, and unpin the data there, and map it accordingly. And now if I open this, we'll just want to rename it so that we know how it's different from the other one. And we want to remove this combined video result and replace that with this final chapter URL, because this is what we'll be combining in this case. So if we execute that step, that can take a while depending on how many chapters and the length of the chapters that you have. When I was doing the 2-hour video, that actually took around 30 minutes for this one to complete. But when that has finished, you should now have your combined video in here, which you can also preview in your browser. And you can see this is 6 minutes because we now have those 3 chapters in here, with this one being the first chapter, this one being the second chapter, and this one being the third chapter. And so now the last step is to just log that video. So we can copy this one, paste that there, map it accordingly here. We can open this so we can configure it and click on unpin. It's still mapped to our main Google Sheets template, but this one will be mapping it to our primary sheet 1 for the ideas. And we just want to rename this into log video, because what this node will do is update the idea that we sourced from sheet 1 in here to put the final video here and also mark this as done. And so to do that, you just want your column to match on to be a row number. And then we want to get the row number from the very first node, which is the get idea node, and just map it there. Now, if in case this turns out to be red for you, what you can try is to change the item word into first so that you can just get this row number since it's one item only anyway. And then if you scroll down, you should find the column for status, which you can now mark as done. And the very final video, if we scroll up in here, you'll find it here in the combined chapters node, which is the node that we just ran. And now if we execute this step, this should now be marked as done and your final video should be logged in here. And there you go. That is the automation in full, where you started with an idea and ended up with a sleep story video that is now ready to publish. Now, the good news about this workflow is that I specifically chose the models that perform well while also keeping the costs down. So with our image generator, Seedream, that's actually the cheapest implementation of this model at only less than 2 cents per image. So if you're creating for a 2-hour video, that would only be roughly 18 cents for 10 chapter images. Chatterbox, the voice model, is also really cheap. So for a 2-hour video, that's only approximately around $2.25. Same with FFmpeg. Even if we call on that multiple times, it's only around 50 cents. And then Rendy, we're using the free tier. So for a whole 2-hour video, that would cost roughly $3 to produce. And in case you're curious what that looks like, this is the generation that I created 10 chapters for a 2-hour video. And so if we open this final node that we set up, you'll see this MP4 file is 2 hours long in total, which I attached to the end of this tutorial. Do note that if you're setting this up, I suggest to just try with a few chapters first to get used to it, because that 2-hour video takes a pretty long time to generate. And also, just as a subnote, you can also extend this workflow in order to upload it automatically to YouTube. But again, I suggest to do this only if you're more advanced and have built up more following for your YouTube channel. Because if you start a new YouTube channel and start to connect automations to it immediately, it's possible that that might lead you to being shadow banned. But if in case you want to learn how to set these up, you can just refer to this earlier tutorial that we published. Or if you have access to Blotato, then that is a much easier setup to do as well. So this is quite a powerful automation once you set it up right. But my advice is if you're going to try and create for YouTube, you need to create videos that people actually find value in. And one of the best ways to check that is to see if the videos that you are generating is something that you would listen to yourself. So when you're thinking about a niche to create for, think about what you yourself would listen to and that you would subscribe to yourself. And that way, whenever AI systems like these create videos, then you can also listen to them and see if you yourself are getting value or not. And if you need some inspiration, there's a lot of examples on YouTube. I summarize a couple of here along with their stats and the best performing ones, just so you see how it works. And along with the template, that is just available in the RoboNuggets community in the link below, where we have dozens more lessons in the classroom all around AI and automation, and where our members also regularly post paid opportunities, including myself, if that's something that you are looking for. So see if that's for you, just in the link below. That's it for this one. I'll see you guys next time. Thank you.
Welcome to Future Lore, a place where the stories of technology and history come alive through simple words and unforgettable tales. Here, we take you on time-traveling journeys, uncovering how our world changed, one innovation at a time. If you love to learn about the past and future of technology, consider liking and subscribing to support more adventures into the wonders of invention and discovery. Tonight, we invite you on a peaceful journey through the story of artificial intelligence. In this video, we start in the era of tiny transistors and travel to the present age of smart computers. You will see how each step built our world, revealed in carefully crafted miniature scenes. The path from early circuits to modern AI is full of wonder. Let us begin. Chapter 1. Welcome to the worlds of technology. Imagine closing your eyes and floating gently above a series of small, glowing worlds. Each one reveals a moment in the story of how machines became smart. Tonight, we start at the very beginning, seeing each step as if drifting slowly through time. Join us as the past unfolds, filled with light and promise. Picture the year 1947. The world is quiet, yet busy with the hum of innovation. Deep inside research labs, the invention of the transistor changes everything. It is a simple, tiny switch, but with it, a new kind of thinking machine is born. These small wonders make it possible for computers to shrink and brighten with life. The journey has only just begun. In these early days, computers were giant and mysterious. They filled whole rooms, each part glowing with soft orange light. Wires and panels clicked softly as people wondered what these machines might someday do. With each new invention, the world seemed to become a little smaller, a little closer. Science was offering new wonders every day. As we move gently forward in time, the 1950s bring more change. The transistor helps computers grow smaller and more powerful. Pastel-colored buttons and glowing panels cover tall machines. Like miniature cities, these computers seem both magical and strange. The hum of technology fills the air, hinting at secrets yet to be unlocked. The 1960s arrive with fresh hopes. Computers leave the lab and enter schools, offices, and even homes. Their shapes echo the styles of the day, with rounded forms and shiny surfaces. Each button pressed is a small step into the unknown. Every light that flickers in these rooms is a beacon for the future, drawing us into new worlds. Now, imagine rows of computers sitting quietly in a classroom. Young minds wander among them, dreaming about the future. These machines seem gentle and full of possibility. They are no longer giant, cold boxes, but instead friendly tools. The orange glow of circuits promises something wonderful is coming. The seeds of artificial intelligence are starting to grow. Let your mind drift to the early adventures in programming. In the 1970s, people used punch cards and blinking screens to talk to machines. Languages are simple, yet they open doors to new knowledge. The world feels smaller as people share programs and ideas. In these calm rooms, the first steps toward intelligent computers quietly unfold. The personal computer arrives like a gentle breeze in the late 1970s. Sleek, compact shapes with curved edges sit on desks, glowing softly. For the first time, many people can welcome this smart technology into their homes. Each click and whir becomes familiar, calming. It feels as if the future has entered the living room, waiting to transform daily life. Through the 1980s, computers grow brighter and faster. Their screens are small windows into new worlds. The pastel glow gently fills rooms at night while people learn and play. Glowing lines trace over black screens, painting dreams of tomorrow. The sound of keys and fans creates a gentle background, soothing and full of promise. As time flows to the 1990s, computers connect across the globe. Soft digital sounds echo late at night, as people discover the power of networks and the magic of the internet. Light spills out from monitors, painting faces with hope. Each connection builds a web of knowledge, inviting everyone to take part in this growing world. The journey continues with the rise of mobile phones. Tiny screens fit easily into a hand, ready to bring the world closer, anytime and anywhere. Black and grey designs, softly glowing, rest in pockets or sit on desks, waiting for a call or a message. Even in quiet nights, the gentle buzz of technology brings comfort and excitement. Picture the simple elegance of first smartphones. Thin and light, their screens shine with soft pastel colours. With one touch, information, music and connection appear. These pocket-sized worlds carry the hopes of a new era. Gently glowing icons rest on smooth surfaces, inviting curious minds to tap and explore in their own quiet time. Each innovation gently leads to the next. Soft curves, glowing lights and pastel colours blend into the look of a brighter tomorrow. In this story, every scene is a tiny world crafted with care. It is as if you are looking at a small model, every detail shimmering with futuristic promise. The adventure is calm, slow and full of wonder. Now, as we move closer to the present day, artificial intelligence emerges quietly behind glowing screens. It listens, learns and adapts, often in ways we barely notice. At first, it seems just a helper, answering questions and making suggestions. But, like the dawn, its gentle presence touches more and more of life, guiding us softly onward. Imagine a world where light and data flow together in harmony. The orange glows of circuits are now joined by waves of information. AI tools read, think and respond with surprising speed. Each interaction feels like a conversation with the future. The world is changed, not with noise, but with calm, clever ideas shared between mind and machine. This story shows that progress can be peaceful and inspiring. From the smallest sparks of invention, a gentle revolution has grown. The miniature worlds we visit weave the story of imagination and hard work, always moving forward. Each era leaves soft footprints for the next, quietly building a legacy of wisdom and hope. As you journey with us, Notice the gentle transitions from one age to the next. The glowing details in every tiny world are clues to how people lived, worked, and dreamed. Each moment touches the next, like stepping stones across a calm pond. The path is winding, but smooth, and always leading towards something brighter. The story is full of symbols, both big and small. A single glowing button, a softly curved roof, or a cluster of tiny glass walls all carry the spirit of their time. These details remind us how technology is shaped by imagination. Every piece of the story fits together, like a puzzle slowly coming to life under gentle, cosmic light. Throughout this voyage, let yourself relax into the gentle rhythm of progress. Technology can feel fast and noisy, but tonight our tale is calm and soothing. Each new idea slips quietly into place, as if settling into a soft bed of memories. The wonders of the past and the future blend together in one peaceful story. From the first circuit to the latest AI, each chapter builds on the last. The story is patient, teaching us that great changes come through tiny steps. Letting go of speed, we focus on gentle discovery. We see how far we have come, pausing to appreciate the journey itself. The path is glowing, winding quietly toward tomorrow. As this introduction comes to a close, prepare to step deeper into the timeline. Ahead, you will meet the worlds of transistors, the rise of personal computers, and the dawn of AI. Each brings its own light and lesson, waiting patiently for us to explore. With heart and mind open, we will walk calmly into history, one small world at a time. So settle in, breathe deeply, and let the miniature landscapes guide your imagination. The story of AI and smart machines is just beginning. By travelling through these tiny glowing worlds, we discover not only the history of technology, but the gentle hope at its heart. The journey will be slow and calm, lighting the way for dreams yet to come. Chapter 2. The Spark of the Transistor. In 1947, a tiny invention forever changed the course of technology. Imagine a time when computers filled entire rooms and bulbs glowed softly in long lines. Those were vacuum tubes, large and delicate, making computers bulky and slow. Then something new appeared, a device small enough to fit on your fingertip, opening up an entirely new future for machines and for us. The transistor was simple in appearance, but mighty in power. It could switch electronic signals on and off far faster than the fragile tubes before it. What used to take up a closet now fit in the palm of a hand. This change meant computers could become smaller, faster, and far more reliable, all thanks to this little switch crafted from the world of atoms. It was the spark that set modern technology in motion. Vacuum tubes had been the giants of early machines, glowing orange and humming quietly in the darkness. But they broke often, ran hot, and took up so much space. Every calculation was slowed by size and frustration. The arrival of the transistor changed that world overnight. Suddenly, machines could be built on a much smaller scale, and possibilities for new ideas began to grow quickly. This invention was not just smaller, it was also tougher and more reliable. No longer did computers overheat or stop working due to a single burned-out tube. With transistors, machines stayed cooler, worked longer, and could do more without taking a break. This meant scientists, engineers, and dreamers could think even bigger, beginning a journey towards smarter and more capable computers. In the world of technology, change often starts with a simple idea. The transistor was tiny, nearly invisible compared to its bulky ancestors, but its impact would echo through every part of life. From radios to televisions, and eventually to computers, the transistor quickly became the heart of modern electronics. The world started to hum with new energy, and bright orange lights seemed to flicker everywhere. Imagine seeing the first transistor, just a small piece of shiny metal and crystal sitting on a workbench. At first glance, it might look unremarkable. Yet, inside, it could control millions of pulses of electricity every second, like a fast heartbeat for machines. With each tiny beat, a new path opened up. The era of slow, lumbering machines was ending, and a new world was just beginning to take shape. The change brought by the transistor was more than just technical. Suddenly, dreams of pocket radios, portable televisions, and quick-thinking computers seemed possible. Cities glowed brighter in the night with small orange lights, symbols of innovation. People began to imagine futures filled with fast, sleek machines, devices that could help with schoolwork or bring music and news to every home, all thanks to this incredible leap forward. Old computers, once as large as a small building, quickly became relics. The transistor shrank entire circuits down to something as light as a feather. Engineers raced to use this invention, rebuilding old machines and designing new ones. Suddenly, entire rooms once needed for computers were left empty, replaced by small cabinets humming with the energy of thousands of tiny transistors. The future was arriving, right there on the desk. With transistors, computers learned to solve problems faster than ever before. What once took hours for a vacuum tube now finished in seconds. People marvelled at how quickly information could travel through glowing lines across a miniature world, guided by the steady pulse of these tiny switches. The dream of artificial intelligence, distant as it seemed, now had its first real foundation sewn into the heart of machines everywhere. The visual world of the 1950s and early 1960s shaped the imagination of future technology. Neon flashes and glowing orange glass met with clean lines and curved shapes in newly designed devices. Each new piece echoed the transistor revolution, smaller, brighter, more powerful. Cafes and homes buzzed with the sounds of radios and televisions powered by these little wonders, filling the air with excitement for what might come next. Transistors brought not just power, but variety. They allowed engineers to try new designs, sleek, rounded and futuristic straight out of dreams. Where once machines looked heavy and serious, now they appeared playful and light, promising a future where anyone might one day work with or even own a computer. The transistor transformed the way people looked at technology and what they hoped it could do. For the first time, computers began to leave the laboratory. Thanks to the transistor, schools, offices, and even hospitals welcomed machines that could calculate, store information, and assist with everyday tasks. This spreading wave of innovation sent ripples through every part of society. No longer was computing reserved for the few, the possibilities had become real for many, lighting up imaginations across the world. Some of the earliest transistor computers looked like pieces from a science fiction movie. Metal panels reflected orange and pastel lights, while buttons glowed softly under glass covers. People gathered in small rooms, amazed by the speed and quiet performance of these streamlined machines. Every light that flickered or dial that spun seemed like a secret promise for the future of smart technology. Tiny as they were, transistors invited the birth of new dreams. Children stared wide-eyed at glowing radios and small screens, wondering what marvels they might use when they grew up. Adults listened and watched, imagining how these sparks of invention might someday help solve bigger problems. Each transistor whispered possibilities for new worlds, where learning, entertainment and discovery fit easily into everyday life. Transistor-based machines could now fit onto a tabletop, no longer confined to glass-walled laboratories. Their hum was softer, their work more dependable. This opened the door for more playful, experimental design curve shapes, bright pastel plastics, glowing orange accents. The world of technology began to feel personal, almost friendly, bringing science fiction a little closer to everyday reality and building anticipation for even greater advances ahead. People soon realized that the transistor did not just shrink machines, it made them affordable. Families that once saw computers as mysterious or unreachable could now imagine owning devices of their own. The gentle glow of new technology moved from office buildings into living rooms and classrooms. The transistor made each step in computing more accessible, paving the way for a creative revolution in how people interacted with machines. Transistors powered not just thoughts but also dreams. As engineers experimented, they found ways to pack more transistors onto a single board. Each improvement made computers quicker, allowing their tasks to become more complex. These advances would soon lead to the next great jump in computer technology, the rise of the integrated circuit bus. For now, the world marveled at how this tiny spark had set so much in motion. Across shiny lab benches and glowing cityscapes, the transistor became a symbol of progress. In homes, soft orange lights showed that the world was changing. People wrote letters on mechanical typewriters as transistor radios played gentle music in the background. The world grew smaller and more connected, piece by piece, as each little transistor found its place inside everyday objects and the story of smart machines slowly unfolded. Everywhere you could see the hopeful fingerprints of this tiny invention. Advertisement posters glowed with promises of speed, clarity, and futuristic comfort. New devices with curved glass, smooth metal, and glowing orange lines appeared in shop windows and movie scenes. The transistor did more than power technology. It fueled a sense of optimism and wonder, shining softly in the imagination of an entire generation. The transistor prepared the world for challenges and opportunities that no one had ever faced before. Each orange glow and crisp signal recalled a promise that machines could be reliable friends and tools in daily life. As these little marvels marched quietly into everything from radios to early computers, society felt the rising excitement of a future growing closer, built from the shimmer of countless electronic sparks. Looking back, it becomes clear how essential the transistor was to the story of artificial intelligence. By making machines faster and smaller, it laid the first stones on the long path to smart technology. Every advance in computing, every new device that learned to reason or adapt, can trace its origins to this singular the moment when tiny switches opened the doors to possible worlds beyond imagination. As the chapter of transistors continued, people began to dream on a scale never seen before. Science fiction became science fact. Each upgrade pointed toward incredible futures, cars that might drive themselves or computers that could converse with humans. Yet in every innovation, the heart of the transistor pulsed quietly, a little reminder of how big change often starts with something small, filled with silent energy and hope. By the end of the 1960s, the rapid rise of the transistor made the next leap possible. Imagination turned into design blueprints, and blueprints became working machines. Computers spread into more and more fields, making the world think about intelligence in new ways. Thanks to the spark of the transistor, society stood on the edge of greater discoveries, the glow of progress lighting up the path ahead. As this chapter closes, remember how the transistor transformed every corner of technology, shrinking the impossible down to size. This small, simple switch became the key to unlocking a future world where even smarter machines could one day exist. In the next chapter, we will see how these changes brought new inventions to life, and how each tiny spark led us closer to the age of personal computers and beyond. Chapter 3. Enter the microchip. In 1958, a breakthrough changed the world of computing forever. With the invention of the microchip, thousands of tiny circuits could be placed on a single chip. Imagine something as small as a fingernail, packed with the details of tangled wires and glowing lights. These tiny worlds would light the path for computers to become smarter and smaller, bringing us closer to the dream of personal technology. The microchip's arrival meant computers no longer needed to fill entire rooms. Now, instead of giant cabinets and endless cables, a computer's brain could fit onto a single, palm-sized piece of silicon. This new compact design opened the door to a wave of creativity. Inventors and dreamers began to imagine a world where everyone could have powerful machines right at home, or even in their pocket someday. Picture a world where circuit boards form cities, glowing softly beneath curved glass and pastel lights. These landscapes, inspired by retro-futuristic dreams, start with a microchip at their heart. Sparkling like orange embers in the quiet dark, each chip becomes a city of information. This chapter of history transformed computers from distant, mysterious machines into tools we could use directly, right at our fingertips. The journey wasn't just about size, it was about speed and power too. Where old computers once waited patiently for each slow calculation, the microchip allowed thousands, then millions of processes to happen at once. Underneath the surface, invisible connections worked together with incredible speed. These chips, shining against sleek black and white backgrounds, made computers faster, more reliable, and ready for even bigger dreams. Thanks to the microchip, a new age of design arrived. Architects of technology began drawing smoother shapes, rounded corners, and glass domes. Computers now looked inviting and futuristic. Each glowing circuit became a building block, stacked into elegant towers of logic and memory. The stage was set for computers to step out of science labs and move closer to where we live, work, and play every day. As microchips grew more powerful, engineers layered them together like intricate puzzles. Each layer added new abilities, making computers more complex and creative. From these tiny structures, waves of numbers and data flowed like neon rivers. With every improvement, the world of technology shifted, hinting at a near future where powerful computers could become as common as household appliances, changing how we live forever. The first microchips made their homes inside simple machines. But very quickly, people imagined more ambitious uses. Soon, these small chips found their way into calculators, radios, and even early video games. Each invention glowed with the promise of what was coming next, a world where technology could fit anywhere. This was the quiet beginning of making smart machines a part of everyday life for everyone. Microchips sparked a new generation of dreamers. Suddenly, young inventors could tinker with powerful tools, imagining computers that anyone could use. The spirit of innovation filled workbenches and garages. New startups and teams formed, hoping to build the future. The air felt charged with potential, each idea lighting up like tiny orange sparks across a night sky filled with pastel shades and sleek science fiction structures. With every passing year, microchips shrank even more. Advances in manufacturing made circuits tinier and tinier, fitting whole cities of wires on a single chip. These miniature landscapes, glowing softly with white and orange light, became masterpieces of design and engineering. The art of building computers felt magical. Each one a handcrafted world so small you could almost hold it between your fingers. The microchip also began to reshape how computers looked and behaved. Instead of tall metal boxes, new computers boasted smooth surfaces and elegant curves. Screens grew brighter, keyboards sleeker. Microchip's quiet power made these changes possible, bringing futuristic aesthetics and clever engineering together in one package. Suddenly, the dream of personal computing didn't feel distant, it was quickly becoming real for a new generation. Imagine stepping into a model city filled with softly glowing towers and glassy roads, bathed in warm orange highlights. This is what the inside of a microchip might look like in our storage circuit, buzzing with activity, each connection working to solve problems in seconds. With the arrival of microchips, the pace of computer evolution sped up, moving us closer to artificial intelligence and the wonders still to come. The race to make faster, smaller, and cheaper computers began. It was a competition filled with excitement as engineers pushed the boundaries of what was possible. Microchips were the secret ingredient letting machines learn faster, solve puzzles quicker, and open doors to possibilities once only imagined in science fiction. From this moment, computers started to feel less like tools and more like companions on our journey forward. A single microchip might look simple when held up to the light, but inside, it's a maze of golden roads and shimmering islands, tucked neatly into layers of black and white material. These tiny inventions held immense power, working together to run everything from space missions to simple games. In every chip, the story of invention and ambition glimmered, reminding us how small details can change the world. As more people welcomed computers into their homes, microchips made possibilities endless. Children could play basic games on home computers. Artists could create digital designs with new tools. Even classrooms began to explore the wonders of technology. All of this was possible because of the microchip, an invisible hero weaving millions of connections, glowing with energy that could fit in the palm of a hand. Microchips also changed how we communicated. Telephones became smarter, linking voices with ease across cities and continents. Messages zipped through metal wires and light beams much faster than ever before. With every new invention that used microchips, the world grew smaller and more connected. The foundations of our digital age began to appear, a web of glowing orange energy tying everyone together in new and wonderful ways. The look and feel of technology began to transform too. Inspired by futuristic art and science fiction, designers used more glass, pastel colours, and sweeping shapes. Microchips drove these changes, allowing devices to shrink while their abilities grew. Rooms once crowded with machines could make space for brighter ideas. The promise of personal computing was bold, stylish, and full of hope, pointing toward a future filled with invention. Imagine the warmth of an orange glow lighting up the edges of a sleek white surface. This was the feeling people had as they first turned on their new computers, an experience powered by the magic inside every microchip. Each startup sound meant new adventures were possible. Whether counting numbers or playing simple tunes, these moments sparked joy and curiosity in families around the globe, shaping the future one chip at a time. Behind every innovation was a team of makers who saw endless possibilities in something so small. They built tools that could store memories, draw images, and play sounds, expanding what people thought machines could do. Microchips became building blocks for progress, quietly supporting dreams big and small. They reminded us that some of the most important changes start with things so tiny, we almost forget they are there at all. Microchips also challenged people to imagine beyond the present. Writers, artists, and inventors filled their stories with ideas of talking computers and machine intelligence. The technology was catching up with their dreams, layer by layer. Each chip was a step toward a smarter, more creative world. The fascination with artificial intelligence and futuristic robots started to feel more real, thanks to the mysterious power packed inside the microchip. Every time microchips grew smaller, more powerful devices followed. Radios, watches, and toys started to include computers. Soon, even the simplest gadgets held hidden worlds of circuits inside them. The ordinary became extraordinary, and life grew more playful and connected. This was the beginning of a future where everything could be improved with a tiny spark of intelligence, a future that felt closer than ever before. The world watched with awe as the possibilities unfolded. News headlines told stories of computers helping to solve big problems and run entire companies. Each headline hinted at a future where technology, once rare and distant, would help change everyday life. The microchip was the bridge, delicate and glowing, powerful and quiet, connecting the ambitions of the past to the amazing world of tomorrow. In retro-futuristic art, microchips often shimmer like miniature cityscapes, their pastel streets lined with towers of black and white. These imagined worlds inspire us to look closer at the technology in our lives. Behind every screen and button, there are tiny landscapes of logic. Even though we can't always see them, their energy and design make modern life possible, and their influence continues to grow every day. As Chapter 3 comes to an end, reflect on how something so small could be so powerful. The story of the microchip is one of creativity, persistence, and genius hidden in plain sight. Every new computer, phone and gadget built on this foundation carries a piece of that original discovery. It's a reminder that our brightest futures often start with ideas that fit inside the tiniest spaces. The journey of the microchip set the stage for a revolution in personal technology. In the chapters ahead, we'll follow these glowing paths further to personal computers, smartphones, and the rise of artificial intelligence. But it all began with that first tiny circuit, a spark of innovation lighting up a world of possibility and calling us to imagine what else might be possible in the world of tomorrow. Chapter 4: The Personal Computer Revolution. In the late 1970s, the world began to change in living rooms and tiny offices. Computers were no longer just for scientists or giant corporations. Ordinary people were finally able to bring these fascinating machines into their daily lives. The story of how personal computers arrived in homes and businesses would set the stage for everything that came next in the evolution of technology. During this period, computers became much smaller and more affordable. Early personal computers often glowed softly with orange screens and were surrounded by the buzz of curiosity. People typed simple commands and saw text appear on the screen. For the first time, families explored games and learning at home, while workers found new ways to write, calculate, and communicate in their jobs. The computer was beginning to find its place. Desk spaces and study nooks slowly started to fill with these new machines. Keyboards clicked and floppy disks spun, carrying digital secrets. Each home computer was like a small portal to a new world. With their pastel casings and tiny screens, these devices invited experimentation. They brought a feeling that anything might soon be possible. The retro-futuristic dream of a computer in every house was becoming real, one blinking light at a time. In offices, sleek personal computers joined grey desks and glass windows. Workers found themselves adapting to unfamiliar routines, learning to type digital memos instead of writing by hand. Glowing orange text replaced the clutter of paper notes. The way people worked began to shift, and new professions quietly emerged. Solving problems with computers quickly became an essential skill. The march of technology meant old habits faded, while new hopes flickered on each screen. Affordable computers sparked a quiet excitement. Children used them for homework and simple math games. Adults tinkered with spreadsheets, curious about this new power. Friends gathered around small boxy screens to play glowing, simple games together. At night, blinking lights reflected off retro desks, filling rooms with a gentle hum. The personal computer became a silent companion in millions of homes, bringing fresh possibilities into everyday routines. In the early 1980s, computer clubs formed in community centres and school gyms. People met to share discoveries, swapping discs and tales about what their machines could do. These gatherings were filled with wonder and laughter. All kinds of people joined in: youngsters, parents, and tech fans. The idea that anyone could learn about computers was spreading quickly. Each meeting sparked curiosity and creativity, helping entire neighbourhoods step into a digital future. Stores with glowing signs welcomed a wave of customers eager to see computers in action. Display units filled with pastel plastics and bright buttons warmed up under ceiling lights. People watched in fascination as salespeople typed commands to make words or images appear. The dream of owning a computer became more real every day. The gentle tapping of keys became the new soundtrack for progress and hope in towns and cities everywhere. By the mid-1980s, schools introduced computer labs lined with shiny, pastel-hued machines. Students sat at rows of neatly arranged desks, staring at softly glowing screens. Teachers encouraged them to program simple shapes or write digital essays. Learning became more interactive and fun with each lesson. For many children, these early days at the keyboard inspired dreams of what technology might bring in years to come. Their imaginations grew along with the technology. At home, families gathered around chunky monitors with squared corners and coloured keys. Parents marvelled at how fast their children learned to use computers. The house filled with the steady click of keys and the gentle whir of disk drives. These sounds became the background music of modern life. Evenings were spent exploring futuristic worlds, creating pixel art, or writing brief, glowing messages. The family computer soon felt as natural as a lamp or chair. Many early personal computers had simple graphics and just a few colours. Screens glowed with bright orange or green against dark backgrounds, reflecting dreams of tomorrow. Software came on floppy disks, cute and square, with handwritten notes to remember what each did. Loading a new program brought anticipation, like opening a small secret door. Each screen flicker offered a window into the possibilities of the future, wrapped in a wave of curiosity and promise. Each computer model, with its unique shape and colour, marked a chapter in this rapidly changing story. Some had rounded, space-age designs, while others looked very practical and square. Companies competed to make their machines faster, smaller, and more affordable. Ads promised that having a computer would unlock a better way to live and work. The promise of progress felt close at hand, with every new box that arrived in living rooms and offices. The personal computer revolution was not just about hardware. It was about new opportunities and ways of thinking. Suddenly, people could write stories, balance budgets, or even create simple music using a device on their desk. Curved monitors and round keys became symbols of hope. Each computer sparked fresh ideas sometimes in the quiet of night, lit by gently glowing screens and dreams of what tomorrow might bring. Imagination thrived in this era. People began to picture jobs that had never existed before: software creators, digital artists, computer teachers. The excitement was visible in playgrounds and offices alike. Parents encouraged children to learn coding and explore computers at home. In classrooms, teachers inspired curiosity with each lesson. The world felt charged with endless possibility as millions took their first steps onto a digital path, guided by soft screens and gentle lights. Throughout the 1980s, bold companies tried new ideas to make computers friendlier. Some models featured colourful buttons or clear plastic cases that revealed glowing circuits. Others came in pastel and white casings, fitting right into retrofuturistic rooms. Designers wanted to spark joy and curiosity, so everyone would feel welcome exploring the digital world. These creative touches helped computers become a warm, inviting part of daily life for families everywhere. Advertising for computers during this time was filled with hopeful dreams. Commercials showed families smiling and children exploring virtual worlds. Offices filled with glowing screens promised efficiency and a bright future. Marketers made owning a computer feel like joining an adventure into tomorrow. The retrofuturistic style of the ads echoed the shiny features of the computers themselves, using lights and pastel colours to make the future look exciting and close at hand. For the first time, people began to personalise their computers. Stickers, soft keyboard covers, and colourful mice made each machine unique. Family photos or drawings were taped to monitors. Users rearranged icons and backgrounds to suit their mood. These small details turned technology into a personal friend, something reliable and comforting. Everyone found their own way to connect with the glowing screen in front of them, making technology feel alive and approachable. The idea of connecting computers together also began in this era. Early enthusiasts experimented with phone lines, linking machines for games and message boards. Digital friendships formed across town and sometimes across continents. These first digital networks were tiny compared to what would come later, but the seeds of a connected world had been planted. With each soft beep and blinking cursor, the vision of a global computer community was growing stronger. Computers influenced how people decorated their spaces at home and work. Desks were chosen to fit boxy screens, and special lights were added to ease late-night typing. Furniture and decor took on hints of the retro-futuristic style, with curves, glass and soft glows. The gentle orange and white lights of monitors cast a peaceful atmosphere. Each workday or evening at home felt a little more magical, shaped by technology and imagination working side by side. Parents began to see computers as important tools for their children's future. They encouraged learning programming basics and exploring new software. Computer skills became as essential as reading or math. Kids dreamed of becoming scientists, programmers, or inventors. Through the personal computer revolution, ordinary homes became launching pads for dreams. The story was no longer about just machines, but about people and their hopes for a brighter world powered by technology. Magazines and books about computers appeared on newsstands everywhere. The covers showed colourful machines, bright screens, and scenes of families working or playing together. Articles explained new concepts in simple words, helping even beginners feel brave enough to try. There were tips, games, and inspirations for everyone. Reading about the personal computer revolution added to the sense that magic was happening, right at home and in every part of daily life. With each new advance, computers became easier to use. Interfaces grew more friendly, with pastel menus and cheerful sounds. People no longer needed to memorize complicated commands. Instead, they clicked on icons and watched as digital folders quietly opened. The intimidation faded away, replaced by a feeling of confidence. The old boundaries between humans and technology continued to blur, as glowing screens became welcoming guides to new adventures. The late 1980s saw even more powerful home computers arrive. Machines got smaller, lighter, and more stylish, fitting neatly into modern rooms. As storage increased, people could do more than ever write long stories, draw digital pictures, or explore virtual adventures. The rapid improvements kept everyone excited. Every year, new models brought fresh abilities, making it impossible to guess what the next big breakthrough might be, or what was just around the corner. Looking back, the personal computer revolution was filled with hope and wonder. Ordinary days suddenly felt futuristic, with every click and beep a promise of more to come. Families, students and workers all took part in this grand experiment. Technology no longer lived only in labs. It thrived in kitchens, bedrooms and small offices. The path ahead was wide open, shaped by millions of dreams brought to life, one glowing screen at a time. In this chapter of technology's story, the revolution of personal computers paved the way for everything that followed: smarter devices, global connections, and the digital world we know today. With their soft pastel lights and futuristic curves, these first home computers proved that technology could belong to everyone. Their gentle glow still shines in the memories of all who saw the dawn of the digital age, as the journey towards smart machines continued forward. Chapter 5: The Dawn of the Internet. In the early 1990s, a new kind of connection began to take shape across the globe. Networks started linking computers together, not just in labs or offices, but across cities and countries. These invisible threads turned the world into a complex living web. For the first time, distant places were a click away. Information flowed faster than ever before. The background hum of computer modems filled quiet rooms as the world discovered the power of being online. Words and images could now travel huge distances in seconds, transforming how people talked, learned, and worked. Dining tables became meeting spots for curious minds as families logged in together, exploring strange new digital lands. The internet was simple at first, yet magical to those who experienced it. Early websites appeared like glowing signposts in the digital night, each one carefully built and full of wonder. People gathered on forums and message boards, meeting strangers who felt surprisingly close, even if they lived on the other side of the earth. This new age felt limitless. Through screens and wires, once isolated homes became connected to a silent, ever-growing community. With every search and each email sent, the world began to shrink in gentle, invisible ways. News travelled at lightning speeds, making events feel immediate, shared, and sometimes overwhelming. The way people learned about the world changed as libraries became digital and answers were always just a few keystrokes away. Curiosity itself seemed to accelerate, pulling humanity toward new discoveries. The internet soon reached into schools, offices, and living rooms, weaving itself into everyday routines. Teachers could bring lessons from faraway lands into their classrooms. Families found new ways to keep in touch, even if separated by oceans or continents. From early chat rooms to simple graphics, every connection planted a seed for future inventions. The world felt more open and exciting. In those early years, dial-up tones and blinking lights became symbols of discovery. Each connection was uncertain, every dropped line a small frustration. Yet, the rewards were worth it. Simple websites held endless possibility. Children marvelled at animated icons, and adults marvelled at email. People began to imagine a future where anyone could share ideas with the entire world. The first web browsers opened up a kind of digital landscapier place where anyone could build, read, or explore. Many websites were basic, with bright colours and clumsy layouts, but each felt like a secret door to somewhere new. The internet made the world feel small, personal, and mysterious. Watching a web page load was like unwrapping a tiny present from another place. As the 1990s moved forward, more people joined the growing web. Friends emailed stories and jokes to each other. Artists uploaded their creations to be admired by strangers. News, music, and ideas bounced across continents. The pace of change grew faster, carrying society into an era no one had imagined before. The internet became a bridge between worlds. Back then, exploring the internet felt a bit like exploring a new city. Each website was a building, each link a winding street. With every new address, people found unfamiliar sounds and sights. Designs were simple blocks of text, a few neon colours, but behind these, whole communities took shape. People began to build friendships that crossed time zones and borders. Even though connections were slow and pictures loaded one line at a time, excitement filled every corner of this digital world. Cafes hosted sessions where people learned how to use search engines. Classrooms buzzed with teachers showing students the web for the first time. The internet was spreading, connecting more homes each day, and laying the first bricks for today's digital society. Night after night, glowing computer screens became windows to faraway places. Families gathered around bulky monitors to chat with relatives or look up recipes. Young people discovered corners of the world they never knew existed. This was the beginning of instant access where questions could be answered quickly, and distant friends felt just a bit closer than ever before. The first webcams and online games appeared quietly, offering playful glimpses into what was coming next. Across the airwaves, early video calls and multiplayer games made geography seem less important. The idea of sharing a real moment with someone in another country felt like science fiction coming true. The world continued to change as bits and bytes raced through cables and antennas. Commerce soon followed curiosity. Markets moved online, changing how people shopped and sold. Small businesses could reach customers far beyond their neighborhoods. The earliest e-commerce sites were simple, but they hinted at a future where shopping could occur from any room. The internet unlocked new freedoms, helping ideas travel quickly and transforming ordinary routines for millions everywhere. After only a few years, life without the web became hard to imagine. Schedules, friendships, and dreams started to rely on digital messages and online calendars. Young people discovered new music on internet radio, while parents paid bills from their kitchen computers. With each passing day, the internet's invisible threads grew stronger, turning society into a delicate but powerful tapestry. As more countries connected, the boundaries of the digital world became harder to see. News from distant lands arrived almost instantly. Translators and online dictionaries helped travelers find their way. The internet encouraged people to share their stories and listen, quietly, to the experiences of others. Bit by bit, cultures mixed and curiosity grew, all moving toward a more open world. Evenings glowed softly with the light of screens, as people browsed for answers or simply explored out of wonder. The sound of an incoming email brought anticipation, an old friend, a new discovery, or a simple smile sent across continents. Internet cafes appeared in every city, welcoming strangers and locals alike. The world was waking up to the possibilities of being connected. Sometimes, the internet felt like a giant library, filled with every book, photo, and story. People learned new languages, found recipes, and read news written far away. Children asked bold questions, searching for answers that might have taken days before. For the first time, there was a sense that anyone could learn about anything at any hour at the tap of a key. The magic of the internet did not lie in cables or blinking modems, but in the people it brought together. Each connection became a thread, weaving a new pattern in daily life. Holidays felt closer as families shared messages, photos, and laughter with those far away. The formation of global communities became possible, making the world a network of shared hopes and dreams. Late at night, some wondered what else the web might become. If today's simple networks could connect so many, what could they do next? New generations began to imagine worlds shaped by instant information. Simple home computers hinted at enormous potential. The internet was only beginning, and everything seemed possible, from richer stories to smarter machines. As the century turned, faster connections and wireless signals changed everything again. Laptops appeared in libraries, college dorms, and coffee shops. People were no longer tied to a single cord or desk. The freedom to take the internet outside made the digital world grow even closer to everyday life. The stage was set for future revolutions in communication and creativity. The glow of night screens invited people into online communities and new friendships. Artists, hobbyists, and learners all found their places among shared interests and ideas. The search for knowledge became as simple as opening a browser. People began to share experiences widely, turning stories and advice into gentle guidance for strangers far away. The web fostered a quiet sense of togetherness. In just a decade, habits that once seemed strange became part of ordinary routines. People ordered books and music never found in local stores. They sent virtual postcards from distant beaches. Conversation moved from dinner tables to digital forums, where thoughts could spread to thousands in moments. The world was now firmly connected, with daily life shaped by the flow of online discovery. As the chapter closes on the dawn of the internet, its soft echoes linger. Those first connections may have been slow, but they pulled the entire world a bit closer together. Across continents and cultures, people met, shared, and learned side by side. The stage was set for the leap from information to intelligence in an era where computers would not only connect but truly understand. The internet's birth was a spark that grew into a steady, gentle flame. It lit up the path toward new technology, creativity, and hope. From tiny signals and slow modems, the journey would soon leap forward. Every byte sent across the web was a promise of what might come next, carrying us all toward a future where minds and machines could learn and dream together. Chapter 6. Computers in your pocket. The mobile phone. In the early 1990s, a new type of technology began to appear in pockets and purses. It was the mobile phone, a device small enough to carry almost anywhere. Compared to earlier computers, these devices seemed light and magical. People could make calls without wires, right from city streets or moving cars. Everything was changing, and soon our lives would look very different. At first, mobile phones looked nothing like the slim rectangles we use today. They were chunky and heavy, sometimes called bricks. But even with their size, they opened new possibilities for connection. Suddenly, you could reach someone at home, in the park, or even while travelling far from the city. The world felt smaller, as if a voice could travel instantly from one end of town to another. Everyday life started to shift. The feeling of carrying a phone was strange but exciting. No longer did you need to search for a payphone or wait by the kitchen wall. Now, a message or call was just a button press away. This fresh sense of freedom was more than convenience. It started to change how people thought about time and place. Daily routines slowly began to revolve around quick calls and instant contact, which used to feel impossible. Before the 1990s, making a call on the move was rare. Only those with special equipment in cars or offices could do it. When mobile phones arrived, they brought this power to ordinary people. The first mobile calls outside the home marked a turning point. Crowded subways and city streets filled with people talking to invisible friends. Everyone started to wonder, what would happen next in this new world? Inside each mobile phone was a small world of technology. Tiny circuits, microchips, and an antenna that could pick up signals from the air. These signals bounced between radio towers standing tall above rooftops and fields. The phone transformed vibrations of your voice into invisible waves, sending your words across neighborhoods and cities in a blink. It all felt a bit like magic, but it was science quietly at work. For many, the first mobile call was unforgettable. The moment felt almost futuristic, like something out of a dream or science fiction show from the past. Parents called children after school, friends made plans from the street corner, and travelers checked in from distant towns. As more people joined the network, the sense of being alone softened. A new kind of connected world was unfolding at their fingertips. As mobile phones spread, whole cities began to change. Tall radio towers dotted city skylines, their signals weaving invisible webs. Even small towns built spots where these new devices could catch a signal. Public places grew quieter as screens and voices replaced hurried footsteps and loud conversations. The outside world slowly became filled with the soft glow of screen lights peeking out from pockets and bags. Mobile phones soon moved beyond calls. Short text messages became popular, letting people share quick notes, jokes, and reminders. Communication became lighter, little bits of conversation carried silently through the air. It was easy to reach out and connect, no matter where you were. The world, once so big and unknown, started to feel cozy and close, just a few keys away from anyone, anywhere. Carrying a phone affected the way people travelled, shopped, and shared experiences. Getting lost became rare, since you could call for help any time. Meeting friends was easier. Plans could change last minute and everyone could stay updated. The strange device in your pocket was becoming a daily companion, not just a tool, but a small piece of the future you could touch and use. Every day, it grew more central in life. By the mid-1990s, millions owned mobile phones. The design began to shift. They grew lighter, sleeker, and more colourful. Flip phones appeared with snapping sounds. Tiny screens showed callers' numbers or glowing orange lights. Some devices even came with games, alarms, or calendars. The simple act of pressing buttons became woven into the way people worked, connected, and played. These little machines were changing what it meant to stay in touch. At night, the lights of the city sparkled, but now, among the neon signs and car headlights, pocket-sized glows flickered everywhere. Connections between friends, co-workers, and family became more constant and spontaneous. It was not just about making calls. It was about belonging to something larger, moving through the world with instant access to voices and laughter, all through a device fitting quietly into a jacket or a bag. The mobile phone was more than a gadget. It started to shape dreams, planning, and creativity. Young people could share secrets late at night with text messages. Businesses closed deals from airport lounges with quick calls. Families used phones for reassurance and support across great distances. For every person carrying one, the mobile phone was now a gateway to a wider, closer, and brighter world, with new possibilities peeking around every corner. Yet, the growth of mobile phones also brought surprises. Suddenly, silence became rare. People expected faster answers, wherever you were. The freedom of voice calls turned into the pressure of always being reachable. For some, this was a gift, for others, a challenge. The line between work and play, home and street, began to blur. Technology was not just outside us, it was travelling with us, shaping how we moved through every day. As the years passed, networks of cell towers grew stronger and more connected. Phones could carry calls farther and more reliably. The idea of missing an important message or being out of contact became less common. Travelling across cities or even countries, people trusted the invisible web of technology to bring voices together. The mobile phone's reach felt endless, always on, always ready for another story or another moment shared. Looking back, the mobile phone marked a leap in human connection. Instead of waiting for letters or searching for public phones, people could speak freely from almost anywhere. This freedom changed family traditions, businesses, and friendships. It made the world swirl a little faster, bringing past dreams of futuristic cities closer to reality. Each call, each simple beep or ring, signaled the dawn of a new era in the story of technology. In the world of miniature wonders, imagine a tiny city with glowing towers and dotted paths, each house glowing softly at night. This was the age of the first mobile phones. Inside every window, a person cradles their chunky device, face glowing bright orange. Outside, cars glide past as signals leap from roof to tower, crossing over pastel rooftops. Quiet conversations fill the air, heard only by those lucky enough to carry a phone in their pocket. Mobile phones paved the path for bigger dreams. Soon after, people wondered, what else could fit inside this pocket-sized machine? Could it handle more than calls and messages? Ideas of sending pictures, browsing the web, or playing digital music began to shimmer on the horizon. The phone, once simple, became the seed for smarter, more powerful companions that would change our lives. Again, this was just the beginning. Every generation that first carried a mobile phone tells the same story: surprise, excitement, and the joy of new connection. Some parents called friends miles away just to share the wonder of it. Children played with buttons, dreaming of endless possibilities. These memories became woven into daily life, filling photo albums, stories, and small moments. The device was more than metal, and Wyatt was a symbol of being together, even when apart. From checkout lines to busy sidewalks, the world changed shape once mobile phones appeared. Waiting felt easier with a friend's voice in your ear. Sharing good news or asking quick questions no longer had to wait. Across neon-lit streets and quiet living rooms, the mobile phone became an everyday part of the landscape. It was the quiet start to a major evolution that would bring even more change in the years ahead. The journey from chunky brick to sleek companion was quick. As new materials and better batteries emerged, phones slimmed down and their power grew. Buttons gave way to touch. Black and white screens sparked with colour. But in the early 1990s, each design was a marvel. Owning a phone felt like holding a piece of tomorrow, a secret link joining you to the network, quietly humming all around the world. Even as technology advanced, people found comfort in simple thing-stalking to loved ones, sending a short message, or just knowing help was close. The mobile phone blended into routines, always there, always ready. It became a modern good luck charm, a constant in pockets and purses. The connection was not only technical, but deeply human, helping people find their way, remember special moments, and sometimes share a quiet word at just the right time. For families separated by distance, mobile phones closed the gap. A child could call a parent from a friend's house in the evening. Relatives travelling far from home could check in with a single ring. Holidays and milestones became easier to share. These devices shrank the world gently, removing walls built by time and space. Their gentle beeps and soft glows became the heartbeat of daily life, always on, always near, always ready. Mobile phones set the stage for the next evolution in technology, the rise of the smartphone, where the world would fit inside a single small screen. But it all began with the excitement of those first mobile calls and the quiet magic of new connections. The journey from chunky bricks to dreaming screens will shape the next chapter. As technology continues to grow, our stories grow with it. As we close this chapter on the first mobile phones, imagine the soft amber glow of a button-lit device, tucked gently in an open hand. These early phones invited the future closer and made every day feel a bit more like tomorrow. The story of technology is a story of shrinking distances and growing dreams. Ahead, even smarter devices wait. Like all moments in this tale, they start with a single bright idea, placed right in your pocket. Chapter 7: The Age of the Smartphone. After 2007, the world started to change at a rapid pace. Phones were no longer just for talking or texting. With the rise of smartphones, a single device put the power of a computer into the palm of your hand. Each touch of the screen brought access to a universe of information, all from anywhere you happen to be. The year 2007 marked a turning point. For the first time, it became possible to browse the web, read the news, and check email wherever you were. Early smartphones featured colourful touchscreens and a playful, futuristic style. As they caught on, more and more people found themselves drawn into digital worlds, all through a slim glass rectangle that fit in their pocket. Streets and parks filled with people gazing at their glowing screens, their faces softly lit by orange and white light, like something out of a retro sci-fi dream. Apps appeared, each one giving new ways to talk, play, or learn. Information once hidden in libraries was now right at your fingertips, waiting for a tap or swipe to reveal it. Smartphones made everything feel faster, more immediate. News broke in real time as notifications appeared. Photos could be shared within seconds, no matter where you were in the world. The boundaries between work and leisure blurred, with emails and entertainment living side by side on the same glowing device. The world felt smaller and more connected than ever before. The evolution of design was striking. Sleek lines, pastel backs and rounded edges echoed retro-futuristic dreams from classic science fiction. Glass and metal reflected the neon signs and city lights of a digital age. Within each phone, millions of transistors worked together, many times more powerful than early room-sized computers. Progress could now be carried in your hand. Smartphones quickly became the heart of daily life. Maps guided people through winding streets with gentle voices. Music and films streamed effortlessly, filling quiet moments with sound and colour. Instant messages replaced letters, shrinking conversations to quick bursts of text. Through each update, devices became smarter, learning to recognise speech and suggest answers. As apps flourished, daily routines changed. There was an application for almost anything you could imagine, from tracking your steps to seeing the weather on distant worlds. Each app was like a tiny tool crafted to fit your needs. This new era turned the smartphone into a digital companion, ready to help, inform, or entertain at any time of day. Even the way people saw the world began to shift. Cameras inside smartphones grew sharper, capturing both fleeting moments and intricate details. Travel memories, city lights, and quiet smiles could all be recorded and shared. With filters and effects, ordinary scenes took on a cinematic glow, each image inviting friends and family into your miniature world. Connectivity was at the centre. High-speed networks linked smartphones everywhere, sending data across the globe in the blink of an eye. Friends could talk face-to-face, even from opposite sides of the world. Video calls, once futuristic, became ordinary. Sharing thoughts or pictures was as simple as tapping a button, weaving people closer together through invisible threads of information. The smartphone also unlocked the internet for billions. Once, going online meant sitting at a desk and waiting for a slow connection. Now, anyone could reach online spaces instantly at home, on the train, or standing beneath the stars. This sense of constant connection brought both excitement and challenge, reshaping how knowledge was discovered and shared. Security and privacy became new puzzles. People started to carry much of their lives in their pockets, photos, notes, schedules, and passwords. Locks and codes appeared, glowing softly on screens as guardians of precious information. The balancing act between convenience and safety grew more important as phones became essential to work, play, and learning. The line between the physical and digital blurred. Payments moved from cash to a digital tap. Tickets, boarding passes, and even books lived inside these pocket-sized computers. Gradually, the world of paper and plastic started to fade, replaced by glowing icons and digital cards. Everyday life took on new shapes, guided by gentle taps and swipes. For businesses, smartphones changed everything. Shops and services moved online, reaching customers anywhere at any time. Small shops could now sell to distant lands with just a few photos and lines of text. Every storefront became both global and local. The smartphone became a tiny showcase, open to anyone who cared to look. Learning brightened with smartphones too. With instant answers and digital classrooms, knowledge became accessible anywhere. Students explored virtual labs, read ebooks, or watched lessons on shining screens. The barriers to information lowered, setting imaginations free to roam through history, science, and the wonders of distant worlds with every curious tap. Games and stories found new life in mobile form. With a tap, entire universes opened, offering both delight and challenge. Players explored pixelated adventures or solved intricate puzzles, alone or together. Even the most complex games could fit into this tiny device, filled with glowing colours and sounds. Entertainment now lived everywhere, carried beside keys and wallets. Work was never quite the same again. Office buildings turned into digital connections, with meetings and projects following people wherever they went. Emails, charts and calendars lived in the same place as family photos and friendly chats. Productivity tools sparkled on screens, ready to help whenever inspiration struck, whether on a train or at a sunlit cafe. Health and wellness transformed as well. Fitness trackers and health apps encouraged people to move, sleep, and eat better. Sensors inside phones and watches quietly measured steps, heartbeats, and sleep cycles, suggesting small changes for healthier living. The line between technology and well-being blurred, inviting new habits shaped by tiny blinking lights and gentle encouragement. Smartphones even changed the way stories were told. Social media and sharing apps invited all to be creators, not just consumers. Everyday moments were turned into art-short videos, tiny texts, and bursts of creativity. The world became a tapestry woven by millions of hands. Each phone another brush adding colour, voice, or spark to the story of technology. As smartphones grew more powerful, they began to sense and learn. Speech recognition transformed voice into commands, making it possible to ask for directions, set reminders, or search for facts using only words. This early intelligence hinted at the next chapter in the story of technology, a world where devices could understand and help in new, almost magical ways. Retro-futuristic dreams lingered at the edges, visible in each phone's sleek lines and glowing screens. It was as if an imagined future from the past had finally come to life, rounded shapes, gentle glows, and handheld worlds humming with potential. Every glance at your device was like looking into a pocket-sized window onto endless possibility. Behind every smartphone, intricate circuits worked in careful harmony. Billions of transistors, tinier than dust, made sense of each tap, swipe, and voice command. The progress from early computers to slim smartphones happened in just a few decades, creating an accelerating sense of wonder. The present felt both dazzling and familiar, futuristic and comforting all at once. The habits of daily life shifted alongside the technology. Morning routines began with glowing screens and gentle alarms. People scrolled through news, replied to friends, and planned their day before ever stepping outside. The smartphone became both tool and companion, a quiet partner shaping how each day unfolded, with a pull as comforting as light in the dark. Smartphones set the stage for what would come next. Their growing intelligence connected perfectly with advances in artificial intelligence, making it possible for devices to help plan, answer, and even anticipate needs. As one chapter closed, the seeds of another began to grow, all inside the slim, glowing shape of the modern smartphone. Looking back, it is remarkable how the world changed after 2007. The smartphone became a symbol of progress melding, the power of computers with the freedom of voice and touch. Through it, people found knowledge, connection, and creativity at their fingertips. The age of the smartphone was both a destination and a beginning, lighting the way for what would come next in the story of AI. Chapter 8: The World of Artificial Intelligence. In the early 2010s, something remarkable began. Computers, once limited to simple instructions, started learning from the vast amounts of data surrounding us. These were the early days of modern AI. Imagine small machines examining countless pictures, hearing thousands of voices, and slowly discovering how to make sense of the world in ways never seen before. Picture a city at night. Lights glowing bright orange through windows. Some of those lights now belonged to computers quietly practicing in the background. These machines learn to recognize images, understand spoken words, and help us with daily tasks. The journey was just beginning, but already the world was changing as artificial minds awoke in our midst and began to assist us in new ways each day. All around, tiny details from past decades blended with new wonders. Retro-futuristic shapes lined city streets, while small glowing screens showed machines helping with maps or spoken questions. For the first time in history, computers could look at a photo and say what was in it, or listen and write down our words. This was not the world of science fiction anymore. It was life, unfolding step by careful step. As the 2010s moved forward, people everywhere started to notice these changes. Phones grew smart, answering questions and predicting weather. On desks, computers helped students research, and in workplaces they sped up tasks. But beneath it all was the real magic machines quietly learning by example, improving each time they received more information. Every day, these artificial minds became a tiny bit wiser. Think of a quiet library, bathed in white and orange glow, lined with thick books and sleek devices. Here, AI learned from datasets as vast as ocean's millions of faces, billions of words. It compared, tested, and tried to find patterns. Soon, it could identify familiar objects or translate phrases from one language to another. Bit by bit, the computer's understanding grew deeper, transforming daily life. Speech recognition was one of the earliest wonders. Suddenly, speaking to a device felt natural. You could say, "Play music," or set an alarm, and the tiny assistant would understand. In kitchens, on nightstands, and at work, these helpful voices grew common. AI turned long strings of sound into clear instructions, listening quietly and doing what was needed with astonishing speed. Elsewhere, artificial intelligence watched moving images frame by frame. Medical machines learned to spot signs of illness hidden deep inside body scans. In grocery stores, cameras counted apples, and robots started to walk in careful lines. AI's vision improved each time it saw a new example, allowing it to help humans in places once thought impossible: hospitals, factories, stores, all transformed in small but vital ways. At street corners, AI managed stoplights, making cities safer and more efficient. Navigation apps suggested faster routes, based on millions of journeys blended together. Underneath these surface details, data flowed like waterways, being sorted, classified, and learned. As technology advanced, the once impossible task of organizing the world's knowledge became achievable, all powered by artificial minds continuously learning. Tiny, blinking servers sat hidden in cool, glowing rooms. They crunched numbers night and day, learning with every step. Patterns, habits, and trends became clear. Suddenly, music services suggested new songs, and stores could predict what you might want before you even searched. AI's understanding of taste and choice made daily life smoother, almost magical, yet it all rested on patient, careful learning from oceans of data. Retro-futuristic shapes appeared not just in cities, but in the devices we held. Small assistants learned to answer complex questions, weather, schedules, recipes through simple voice commands. Sharp lines, glowing lights, and pastel screens disguised the powerful intelligence humming beneath the surface. Each new device, whether a phone or smart speaker, was another step forward for artificial intelligence, seamlessly blending into our routines. In 2012, a breakthrough moment arrived. AI finally began to surpass old limitations in vision and speech. Powered by special neural networks, computer systems learned to identify image scats, cars, and faces with accuracy never before seen. This moment changed everything. Researchers saw that by feeding computers more data and greater detail, these machines would keep improving, learning faster and thinking deeper. Factories filled with sleek shapes and glowing details came alive with AI. Machines moved on their own, assembling tiny parts with precision. Cameras checked each step, guided by invisible artificial eyes. As the sunset poured orange light through tall glass roofs, each robot's careful movement revealed a world advancing quietly, where human ideas and artificial minds assembled the future, piece by piece, day by day. Language, too, became a new frontier. Artificial intelligence learned to understand jokes, answer questions, and even write messages. No longer limited to numbers and simple words, computers tried to make sense of human speech. The more they listened, the better they became. Digital conversations soon felt natural, as if a helpful friend was there, ready at any moment to assist with almost anything you could imagine. Imagine a small child walking through a bustling retro-futuristic street, gently holding a parent's hand. The world vibrates with silent intelligence. Billboards change automatically, guiding families. Overhead screens translate languages for tourists. Each hidden AI system watches, learns, and supports the flow of the crowd. Human life, now interwoven with digital minds, feels both safe and endlessly new. It's a calm revolution spreading everywhere, softly at first. The 2010s ended with a world newly aware of artificial intelligence's power. Homes filled with gadgets that listened, watched, and remembered preferences, from lighting to temperature to daily routines. This web of helpful machines linked together, quietly supporting people. Each small device, glowing in the pastel light of evening, carried the patient knowledge gained from billions of shared experiences, always striving to make life a little brighter and easier. Schools joined the transformation. AI-powered learning apps helped students practice math, reading, and even languages. Instant feedback replaced waiting for test results. Across glowing screens, learners felt more supported, guided step by digital helpers, always ready to explain and encourage. In this world, classrooms merged books and tablets, chalk and data, blending old traditions with the promise of new, AI-driven understanding. Even the everyday world outside changed shape. Streets pulsed with smart lighting that adapted to foot traffic. Small delivery robots rolled along sidewalks, guided by silent AI. The familiar retro-futuristic buildings, with their angled roofs and glassy walls, sparkled under the glow of technology. All this progress came quietly, bit by bit, powered by artificial minds always watching, learning, and serving the life of the city. Entertainment was transformed as well. AI wrote music, suggested movies, and made video games more exciting. People watched shows tailored to their tastes, as if the story understood exactly what they wanted. In movie studios and on living room screens, artificial intelligence blended sound and picture with stunning precision, creating joyful moments and unforgettable journeys, all thanks to the power of machines that learned from us. Shopping changed in subtle ways. As you browsed, invisible AI helpers tracked searches, suggested products, and could even match your style preferences. The world became smoother and more personal. With each click, orange lights reflected softly on screens as the systems quietly learned to understand what you liked. The experience felt seamless, almost as if the stores themselves were thinking alongside you, creating a comforting sense of connection. transportation entered a new age with AI behind the wheel. Early self-driving cars appeared, guided by sensors and artificial vision. They followed the simplest instruction: stop, go, turn, learning from millions of trips. Each journey became part of the data that fueled smarter decisions. Retro curves and shining glass sheltered passengers, while gentle orange interior lights glowed as vehicles rolled into the future, all powered by learning machines. Healthcare advanced at an incredible pace. Brain scans, heart monitors, and patient histories were analysed faster than ever before. Hospitals turned into places where doctors and AI teamed up, catching health problems sooner. Machines spotted signs invisible to the human eye, working all night in gentle silence. This partnership saved lives, showing how the union of artificial minds and compassionate humans could lead to a healthier world for everyone. The wave of artificial intelligence created new questions too. People wondered about privacy, safety, and the role of machines in society. Still, the spread of AI inspired hope and possibility. As orange neon reflected against white walls, a sense of wonder grew. Every tiny assistant, from pocket devices to large computer networks, stood ready, calm and steady, reminding us that technology's story was far from over. In the end, the 2010s marked the true dawn of the AI era. Everyday life, in cities glowing with pastel lights and retro-futuristic shapes, became woven with the quiet help of artificial minds. Machines that listened, watched, and learned, gently guided humans through a new kind of world. It was a time of wonder, calm progress, and hope, setting the stage for even greater transformations still to come in the unfolding future. As the chapter closes, picture the city at dusk, glowing orange along the horizon, alive with infinite possibilities. AI has become not just a tool, but a quiet companion to humanity. Each day, artificial intelligence continues to grow, gently supporting, learning, and dreaming alongside us. The story of AI is still young, filled with endless new chapters waiting in the dusk and the glow of tomorrow's light. Chapter 9: Large Language Models and the Rise of Chatbots. In the early 2020s, computers gained a startling ability to understand and use language. What began as simple text prediction evolved into systems that could answer questions, write stories, and even hold lifelike conversations. These tools, often called large language models, forever changed the way we interact with technology. Imagine talking to your computer as easily as chatting with a friend and being understood. In this chapter, we explore how these new computer programs, built on vast libraries of text, started to shape our daily lives. Businesses, artists, students, and everyday people all found ways these models could help writing emails, composing poems, and even brainstorming new ideas. These AI companions were not just smart, but also creative, surprising, and sometimes just a bit uncanny, opening doors to conversations we never thought possible. A key turning point arrived around 2022, when large language models became widely available. Systems like ChatGPT captured the world's imagination. For the first time, software could answer nearly any question in an instant, explain complex ideas in simple words, and even crack jokes or compose music. What made them special was how natural these conversations felt, blending intelligence and empathy in a way machines never had before. To build these new models, computers were trained on enormous collections of books, articles, and web pages. They studied language by processing billions of lines of text, learning how words fit together, and what people usually mean when they ask a question. The process took many months and required powerful computers working day and night, highlighting the scale and ambition of this new era in artificial intelligence. These chatbots soon found homes in many places. You could ask them to help write a story, solve a tricky homework problem, or recommend a movie based on your mood. Teachers began using them as tutoring assistants. Customer service lines became easier to use, with bots that understood your questions and responded helpfully. Even scientists and doctors asked these models for advice, unlocking new ways to learn and grow. The rise of large language models was not just about smarter computer sight, it was a cultural shift. For decades, talking to a machine felt awkward and limited, like entering commands into a calculator. Suddenly, technology could hold real conversations, blending information, humour, and patience. For many, it felt like science fiction made real, no longer having to translate thoughts into code, but simply talking and being heard. But how do these models really work? At their core, they are built from layers of mathematical instructions called neural networks. Each layer processes a piece of text, looking for patterns and relationships. As information passes through the layers, the model slowly builds an understanding. It predicts what should come next in a sentence or conversation, drawing from what it has seen before. This is the secret to their lifelike responses. A key ingredient to their success is scale. Early models worked with millions of lines of text, but by the 2020s, new models learned from hundreds of billions of words. The more they read, the more fluent they became able to switch between languages, answer detailed questions, or mimic different styles of writing. This scale required massive computer power, but the reward was breathtaking machines that could reason, create, and converse. Every interaction with a chatbot is shaped by previous conversations. The more people use these systems, the better they get at understanding what matters, what words mean in context, and how people express themselves. Developers constantly update these models, fine-tuning their knowledge and correcting mistakes. In this way, language models became a kind of living technology, always learning and evolving. Their rapid rise sparked new questions. If a computer can answer emails or draft news articles, what does that mean for writers and teachers? Some worried about jobs changing, others saw new opportunities. Many asked how to make sure chatbots provide reliable, safe advice, especially for health or legal matters. These challenges pushed both engineers and society to find ways to build trust and encourage creativity. Despite these questions, excitement continued to grow. Artists collaborated with chatbots to generate poetry or visual art. Programmers built games powered by AI storytellers. Kids experimented with models that could tell them bedtime stories never heard before. Each use revealed new surprises, showing how these systems could adapt, inspire, and even entertain, all from a simple text box on a screen. Large language models also made it easier for people around the world to connect. They could translate languages in real time, helping travelers find their way, or students understand new subjects. Businesses reached across borders with automated messages that felt personal. Barriers that once separated people began to shrink as computers helped bridge gaps in understanding with effortless communication. Not all interactions went smoothly. Sometimes chatbots misunderstood questions or generated incorrect information. These mistakes reminded everyone that language models, as powerful as they were, still had limits. Engineers introduced tools to help spot errors, and users learned to double-check facts. This ongoing partnership between humans and intelligent machines became key to unlocking the full promise of AI. With each year, language models became part of daily life. From smartphones and smart speakers to cars and home assistants, their presence was felt everywhere. People grew used to asking for news or weather by voice, searching for recipes by chatting, or planning a trip using a friendly virtual guide. What once felt futuristic became second nature, a new way to experience the world through conversation. Some people wondered if talking to computers would change how we think and feel. Would it make us more creative, more curious, or more dependent on technology? Many found that having a digital partner helped them express ideas or learn faster. Others liked the comfort of always having someone or something to listen and respond. This shift in how we relate to machines became a defining feature of life in the 2020s. New projects appeared almost overnight, each trying to push language models further. Companies released updated chatbots every few months, each with more skills and a bigger vocabulary. Open platforms allowed anyone to create their own AI assistant, tailored to personal needs. From recipe helpers to travel guides, the landscape filled with tools that made computers more personal, more helpful, and more fun. The learning never really stopped. As these tools grew, they started to handle more than just words. Large language models learned to work alongside images and sounds, opening up new ways to create music, edit photos, or describe objects in a scene. These advances showed how close computers were to understanding the world as people do, blending senses to create entirely new kinds of experiences. Through it all, curiosity remained at the heart of progress. Each question, each conversation, pushed systems to improve. People used language models for research, entertainment, problem-solving, and even friendship. By inviting AI into daily life, society learned new ways to think about intelligence, what it means to know, to create, and to connect with one another in the digital age. Safety and privacy became more important than ever. As chatbots handled private messages or business secrets, people wanted to know their information was safe. New protections and ethical rules were created, guarding against misuse. Clear guidelines helped people use these tools wisely, encouraging trust while still welcoming innovation. The story of AI was now one of partnership and responsibility, shaping the world together. As language models matured, their influence was seen in every part of life. Education, healthcare, art, and business all changed. Teachers used AI to explain tough topics. Doctors used chatbots to keep up with research. Artists found inspiration from computers who could brainstorm or spark ideas. The future seemed full of possibility as people and machines learned from each other, growing side by side. By the mid-2020s, the boundary between human and computer conversations faded. What once required typing and clicking now happened naturally, with spoken words and shared understanding. New hardware, like smart glasses and wearable devices, made these interactions even easier. The world felt more connected and more alive, each person carrying a pocket-sized partner, always ready to listen, think, and help. Looking back, the rise of large language models marked a dramatic turn in the story of AI. What began as code and lines of text became a bridge away to connect ideas, solve problems, and spark creativity. The journey was not always smooth, but each step forward brought technology closer to people. The future, once imagined in dreams and stories, became something everyone could now share. Large language models invite us to ask big questions. How should we use this technology? What will human creativity look like with machines as partners? As the story of AI keeps unfolding, these conversations shape what comes next. The rise of chatbots is just one chapter in an ongoing adventure where imagination, intelligence, and kindness guide the way to new discoveries. As we end this chapter, imagine a world where anyone can talk to computers as easily as speaking with a wise friend. With each exchange, both people and machines learn and grow. This partnership, built on language and curiosity, lights the path to a future filled with connection, discovery, and wonder. The journey of AI continues, driven by questions, creativity, and the quest to understand. Chapter 10. Tomorrow's Dreamscape. The future of AI. As we come to the end of our journey, imagine a world quietly glowing with the light of progress. The story of AI is not closing here. Instead, it is just beginning to open new doors. Beyond the 2020s, computers and artificial intelligence promise to change our lives in ways that are gentle, creative, and full of wonder. With each passing year, AI becomes more deeply woven into the fabric of our world, helping us learn faster, dream bigger, and solve problems once thought impossible. Picture classrooms where every student is guided by a careful digital mind, or artists making music and stories side by side with curious machines. The ordinary becomes extraordinary as AI works quietly in the background. In this unfolding dreamscape, AI connects people in ways that feel warm and immediate, even when they are far apart. Smart language tools make conversations easier across distant lands. New inventions sparkle each day, inspired by both human minds and intelligent code. Each glow along the city skyline hints at technology built to serve, create, and celebrate human feeling and creativity. Every morning, millions wake up to a world filled with digital companions. These smart machines help with schedules, reminders, and even with lighting up homes to welcome a new day. Voice assistants greet us by name, and chatbots answer our weirdest questions at any hour. It almost feels as if these devices know us, learning what we want, when we want it, making daily life smoother with each sunrise. AI is not just hidden in phones and laptops. It's found in creative corners everywhere. Picture art generators that transform simple ideas into vivid pictures, or tools that can write stories, poems, and music at the tap of a finger. Translators turn unfamiliar languages into friendly words. These smart systems let imagination leap over barriers, making creativity something that everyone can share. The world grows smaller and brighter with each new invention. But behind the scenes, there's even more happening. AI is busy learning from everything it sees and hears. It sorts through mountains of messages, photos, and videos every second. Like a tireless student, it looks for patterns, remembers past lessons, and tries to offer better answers every day. The more we use these tools, the more they adapt, quietly getting smarter with every interaction, just by being part of our everyday lives. This new age feels both exciting and sometimes puzzling. It's amazing to see machines paint portraits or compose melodies, things that once felt possible only for humans. Sometimes AI even surprises us, doing something we never expected. It might solve a stubborn problem or dream up a design no one's imagined before. There is a sense of wonder in this partnership, as if our world grows wider each time we trust technology. However, with these wonders come thoughtful questions. What happens when machines do things human minds can't predict? How do we make sure these tools stay friendly, honest, and fair for all? People everywhere are talking, sharing hopes and worries about AI's growing abilities. We want technology to lift everyone up without leaving anyone behind. The partnership between people and machines is still actively unfolding, inviting both caution and hope. Smart machines are also finding a home in industries and workplaces. In hospitals, AI helps doctors discover illnesses faster and plan better treatments. In factories, robots team up with people to build cars and create medicines. Out in cities, traffic lights use AI to ease rush hour, saving time and energy. Everywhere you look, the world is adjusting and adapting, learning new ways to work alongside artificial intelligence. Kids today are growing up in a world their grandparents could barely imagine. Homework helpers are powered by AI, answering tough questions and showing step-by-step solutions. In classrooms, lessons can shift and change to match how each student learns best. This is a time when knowledge flows in fun, surprising paths, where smart machines are not science fiction, but tools that help children dream even bigger than before. Even in entertainment, AI makes a difference. From games that learn your style to apps that mix custom music playlists, it's clear that creativity is no longer just about what humans can do alone. Movies suggest their next scene, stories unfold in new ways, and virtual friends appear on screen. The future of having fun is now being shaped in these fresh and unexpected ways. all by the quiet work of smart machines working in the background. Communication is faster and easier too. Text messages zip across languages in an instant, helping people stay connected across continents. AI helps block spam, corrects spelling, and offers smarter suggestions for words. Even video calls use AI to sharpen sound and picture, making everyone feel closer despite the distance. This blend of old-fashioned friendship and new technology is changing the way we reach out to others every day. But, as the world grows more connected, it also grows more complex. We must ask how much we should trust the suggestions and choices of machines, and where our own judgment fits in. Today's partnership with AI raises big questions. What do we want these tools to do, and what should they always leave for humans to decide? These are the thoughtful challenges guiding the next steps in our shared story. Across the globe, teams of engineers and dreamers build new forms of AI. They teach these systems to recognize voices, understand pictures, and even hold conversations. Every improvement opens another door, letting machines help with more tasks, and giving people new ways to explore ideas. These advances are arriving fast, changing what's possible in business, science, and our everyday adventures alike. Many of today's achievements can be traced to giant leaps in computer hardware. Decades ago, one computer filled an entire room. Now, small chips hold more memory and power than early machines ever dreamed of. These breakthroughs turned silent, boxy computers into friendly helpers that answer when we call. Our story is shaped by this shrinking and speeding up of technology, making intelligence available to everyone. The journey to AI as we know it involved many stepping stones. It started with humble beginnings, like the first transistors in the 1940s, tiny switches that made computers possible. Later, the personal computer changed homes forever in the 1980s, followed by the rise of smartphones in the early 2000s. At every turn, machines grew smaller, faster, and more familiar setting, the stage for the smart assistants we use today. AI now has the power to sift through tremendous amounts of data. For example, smart machines can scan thousands of medical images in moments, catching details even experienced eyes might miss. In financial systems, AI helps guard against fraud and predict market trends. This capacity for fast, careful work makes artificial intelligence a helpful partner in solving puzzles that would take people far longer than before. Yet, the spread of AI has also sparked debates about privacy and fairness. As machines analyze mountains of information, we need to decide how much to share and how it's used. Do algorithms treat everyone fairly? Are decisions transparent and easy for people to understand? The thoughtful design of AI matters just as much as its cleverness, and the choices we make today will shape the future relationship between people and technology. AI changes not just how we work, but how we imagine new ideas. Artists use smart tools to sketch concepts never seen before. Inventors test wild designs in virtual worlds, and researchers run experiments in seconds that once took months. All around us, innovation moves faster, powered by a partnership that blends human dreams with machine skill. It's a wave of possibility that invites everyone to contribute and create. Accessibility is a key gift of today's smart machines. For people with disabilities, AI-driven devices read text aloud, describe images, or help guide users through unfamiliar places. Language barriers fall as translators work instantly. Technology now welcomes more voices and talents into every conversation, helping to build a future where more people are included and where everyone's abilities are valued and celebrated. Although machines are incredibly advanced, there is still a limit to what they can do. Human judgment, empathy, and creativity continue to play an irreplaceable role. Smart machines may offer suggestions or ideas, but people still shape the final decisions. This partnership is a new kind of teamwork, combining bright code with bright minds. Together, we're finding new solutions by trusting both human wisdom and artificial insight. As technology moves forward, so must discussions about responsibility. When an AI makes a big choices, such as recommending medical treatments or handling someone's security, who makes sure it's fair? Can we improve these systems so they listen to more voices and reflect many kinds of experience? These questions are vital, as more parts of life depend on the careful partnership between humans and the machines we create. The future is bright, with exciting challenges still ahead. Researchers work every day to create AI that's more helpful, more creative, and more caring. By learning from mistakes and listening to different points of view, the world of smart machines can grow in ways everyone can trust. Our optimism is fueled by the idea that technology will serve the common good, creating opportunities while protecting what matters most to us all. Despite these hurdles, hope shines bright. Around the world, scientists, artists, teachers, and regular people collaborate to shape AI into a helpful companion. They guide its growth with honesty and care, aiming for tools that lift everyone up. The story of AI is still being written, and every decision today shapes tomorrow's world. Seeing AI as both opportunity and responsibility, we all have a hand in building a better future.